3 hours. That's how long we'll stare into structures that refuse to behave like accidents. Stone circles aligned to impossible precision, temples tuned to the language of numbers, monuments whose measurements echo the sky itself. These are not myths, they exist, carved and calculated with an accuracy that challenges our timelines and our assumptions. Who taught ancient builders to think this way? What knowledge was measured, mapped, and sealed into stone? Tonight we trace the math beneath the mystery. So sit back, steady your curiosity, and let's descend into the evidence. High in the misty highlands of West Java, Indonesia, Gunung Padang rises quietly above the surrounding farmland. From a distance, it looks like a forested hill, unremarkable and ancient in the way many volcanic landscapes are. But as one climbs its terraced slopes, the ground begins to change. Basalt columns, dark, angular, and carefully arranged, emerge from the soil, forming steps, walls, and platforms that feel deliberate rather than natural. The air is cool, the silence broken only by wind and insects, and yet there is a persistent sense that this hill is not merely a product of geology. Gunung Padang has long been known to local communities, regarded as a sacred place. In Sundanese tradition, it is associated with legends of ancestral builders and unfinished works left behind overnight. For decades, archaeologists classified the site as a megalithic complex, likely dating to the late Neolithic period, roughly 2500 to 1500 BC. The visible terraces, aligned stones, and ritual platforms seem to fit within what was already known about prehistoric cultures in the region. People capable of organizing labor, shaping stone, and creating ceremonial spaces on elevated ground. Yet beneath those terraces lies the source of growing intrigue, the so-called columnar chambers. The surface structures of Gunung Padang are built from naturally occurring columnar basalt, formed when lava cools and fractures into polygonal pillars. These columns are found across volcanic regions worldwide, and at first glance, their presence here seems purely geological. What complicates the picture is how they are arranged. Many appear stacked, aligned, or embedded in ways that suggest intentional placement. Subsurface surveys using ground-penetrating radar, seismic tomography, and electrical resistivity have revealed layered anomalies beneath the hill, rectilinear patterns, void-like spaces, and dense formations that do not neatly resemble untouched volcanic rock. Some researchers interpret these findings conservatively. In this view, Gunung Padang is a natural volcanic hill later modified by human activity. The upper layers, they argue, were reshaped into terraces and platforms for ritual use, while deeper anomalies represent fractured lava flows, collapsed cavities, or natural voids common in volcanic terrain. From this perspective, the chambers are not chambers at all, but the result of complex geology interpreted through imperfect instruments. Others are not so certain. A more controversial hypothesis proposes that Gunung Padang is not simply built on a hill, but is the hill. According to this idea, humans may have reshaped an entire volcanic core, reinforcing it with stone layers and internal structures over thousands of years. Some interpretations of core samples suggest worked stone, compacted fill, and materials that appear out of place for natural formations. Radiocarbon dates taken from organic material within deeper layers have yielded startling results, with some samples pointing to dates as early as 9000 BC or even earlier. If those dates reflect human activity rather than contamination or natural processes, they would dramatically alter current understandings of civilization. Such a timeline would place large-scale construction far earlier than accepted models of social development, long before agriculture was thought to be widespread, let alone monumental architecture. This is where the idea of columnar chambers becomes most provocative. Proponents of the deeper structure hypothesis suggest that beneath the visible terraces lie intentionally constructed spaces, reinforced cavities, corridors, or chambers formed by arranging basalt columns in stable configurations. These spaces, they speculate, could have served ceremonial, acoustic, or symbolic purposes, or perhaps functions no longer understood. Others imagine the possibility of a buried core structure, sealed and layered over time as knowledge or populations changed. Mainstream archaeology urges caution. Dating material found between stones does not automatically date the stones themselves. Volcanic landscapes are dynamic, subject to shifts, collapses, and natural layering that can mimic human design. Instruments can suggest shapes, but excavation is required to confirm them, and excavation at Gunung Padang is limited, both by preservation concerns and by debate within the academic community. Still, questions remain. Why does the site show such consistent orientation? Why do some subsurface patterns appear repeated across different survey methods? And why has Gunung Padang been revisited, modified, and revered across so many periods of history? What is clear is that Gunung Padang resists simple classification. It exists in a gray space between nature and culture, between hill and monument. Whether the columnar chambers are engineered spaces or geological coincidences, the site reflects a long human relationship with landscape, one where stone, belief, and memory intertwine. As research continues and methods improve, Gunung Padang remains largely intact, holding its secrets beneath layers of earth and basalt. The question is not only what lies below the surface, but how much of the past we are prepared to reconsider if those stones were shaped by hands far older than we expect. As the questions surrounding Gunung Padang linger, about layers of time, hidden structures, and knowledge that may have surfaced far earlier than expected, the journey quietly shifts westward. From a volcanic hill wrapped in mist, we move to a dry northern plain, where the earth tells a different story, but whispers the same uncertainty. Tel Qaramel rises gently from the landscape of northern Syria, not as a dramatic mountain or towering ruin, but as a low, unassuming mound. From afar, it blends into the terrain, its contours softened by millennia of wind and dust. Yet beneath this modest hill lies one of the most intriguing archaeological sites of the early human world. Excavations here reveal something unexpected. Circular stone towers built long before cities, long before writing, and possibly long before agriculture was fully established. The site sits near the Quake River Basin, a region that once supported mobile hunter-gatherer groups transitioning toward more settled lives. Archaeological work at Tel Qaramel began in earnest in the late 20th century, uncovering a sequence of occupation layers that reach deep into the pre-pottery Neolithic period. Radiocarbon dating places the earliest structures at roughly 10,500 to 9,000 BC, making them among the oldest known stone towers ever discovered. At least 5 circular towers have been identified so far. They vary in size but share common features: carefully laid stone walls, central pillars or internal partitions, and deliberate placement within the settlement. These were not piles of rock stacked haphazardly. The stones were selected, shaped, and positioned with consistency. The geometry is unmistakable: circles measured and maintained, walls balanced, spaces defined with intent. From a conventional perspective, the towers are interpreted as communal structures. They may have served as gathering points, storage facilities, or ritual spaces, places where early communities came together to coordinate, observe, or remember. Some archaeologists suggest they were symbols of emerging social cohesion, marking a shift from purely mobile lifestyles to ones rooted in place. And yet, questions quickly arise. Why build towers at all, especially at a time when survival demanded efficiency and mobility? Why invest labor into stone architecture before the widespread adoption of farming? And perhaps most curiously, why circles? Circular construction requires planning. It demands a sense of proportion, spatial awareness, and repeated measurement. At Tel Qaramel, the curvature of the walls is remarkably consistent, suggesting more than intuition. The builders may have used cords, stakes, or other simple tools to maintain symmetry, techniques that imply an early understanding of geometry, even if not expressed in numbers as we know them today. Some towers appear aligned with one another, and possibly with features of the surrounding landscape. While no definitive astronomical function has been confirmed, the possibility has not been dismissed. Other early Neolithic sites show clear concern with orientation toward cardinal directions, seasonal changes, or prominent natural markers. Could these towers have played a role in tracking time, signaling events, or structuring communal rituals around cycles larger than daily survival? Mainstream archaeology remains cautious. There is no clear evidence that the towers functioned as observatories or mathematical monuments. The alignments may be coincidental, the geometry simply practical. Circular buildings, after all, are structurally stable and efficient, distributing weight evenly without corners that weaken over time. Still, the repetition is hard to ignore. Tel Qaramel was rebuilt again and again over centuries. Each phase respected what came before, sometimes incorporating earlier structures rather than erasing them. This continuity suggests memory, a cultural insistence on preserving form and placement. The towers were not random experiments, they were part of a tradition. More speculative interpretations venture further. Some propose that the towers served as symbolic anchors, representing order imposed on an uncertain world. In this view, geometry itself carried meaning. The circle, without beginning or end, may have reflected ideas of continuity, cycles, or balance. Building such forms could have been a way of expressing knowledge, belief, or identity long before such concepts were recorded. Others wonder whether these structures played a role in social regulation. Elevated platforms or enclosed spaces could have been used for observation, initiation rites, or decision-making, functions that require separation, visibility, and control of space. If so, the towers may represent early steps toward organized governance, encoded not in law, but in architecture. What remains unresolved is how much the builders truly understood about what they were creating. Were they consciously applying mathematical principles or following inherited rules refined over generations? Did the precision emerge from deliberate calculation or from long trial and error guided by shared memory? Excavations at Tel Qaramel are ongoing, and like Gunung Padang, much of the site remains untouched. Each new layer adds clarity, but also complexity. The deeper archaeologists dig, the earlier structured behavior appears, challenging long-held assumptions about when humans began to think in terms of abstraction, symmetry, and permanence. In the quiet stone circles of Tel Qaramel, there is no inscription to guide interpretation, no voice to explain intent, only form, repetition, and time. And as these towers stand, older than monuments once thought to be humanity's first, they invite a lingering question. What else did early humans know, measure, or imagine that has yet to be fully uncovered beneath the soil? From the quiet stone circles of Tel Qaramel, where early communities traced meaning into geometry, we move forward in time and far across the world to a landscape once thought incapable of sustaining complexity. Here, the mystery is not carved from stone, but drawn directly into the earth itself. In the southwestern Amazon basin, in what is now the Llanos de Mojos of Bolivia, the land stretches wide and flat beneath an immense sky. During the rainy season, water blankets the plains, transforming them into shallow inland seas. For much of the year, the region appears hostile to permanent settlement, too wet, too unpredictable, too fragile. And yet, just beneath the grass and forest canopy, vast geometric patterns begin to emerge. These are the Kasarabi Amazonian earthworks. From the ground, they are almost invisible. Low platforms, shallow ditches, raised roads softened by centuries of erosion. But from the air, their true scale becomes unmistakable. Rectangular enclosures, precise causeways stretching for kilometers, stepped pyramidal mounds, and carefully planned canals form an interconnected network across hundreds of square kilometers. The shapes are deliberate, the spacing is consistent, and the design suggests a level of planning that was once believed impossible for this environment. For much of the 20th century, the Amazon was described as a pristine wilderness, sparsely populated by small, isolated groups. The soil, it was thought, could not support large populations or long-term urban planning. The Qaramel earthworks challenge that idea quietly but decisively. Archaeological research, supported by LiDAR scanning and excavation, has dated these structures primarily between roughly AD 500 and AD 1400. They are associated with what researchers now call the Qaramel culture, a society that appears to have engineered the landscape rather than dominating it. Raised fields elevated crops above floodwaters. Canals controlled the seasonal flow of water. Causeways linked settlements even during inundation, maintaining connectivity year-round. At the heart of many sites are large, flat-topped mounds, some rising more than 20 meters above the plain. Around them, geometric enclosures, rectangles, squares, and occasionally more complex shapes, are laid out with striking regularity. Roads radiate outward, connecting one center to another, forming what some describe as a low-density urban network. The mathematics here is subtle, but persistent. Distances between sites are often consistent. Angles appear intentional. Causeways run straight across uneven terrain, suggesting surveying and long-range planning. While there is no evidence of written measurement systems, the layout implies shared standards, rules for spacing, orientation, and proportion passed down across generations. Mainstream interpretations view this as an example of sophisticated, yet sustainable, landscape engineering. Rather than dense cities of stone, the Qaramel built with earth, water, and time. Their architecture was not meant to dominate the skyline, but to function in rhythm with seasonal cycles. Geometry, in this sense, was practical, a way to manage space, resources, and social organization efficiently. Yet even within this framework, questions remain. Why such large ceremonial platforms? Why enclosures far bigger than what daily life alone would require? And why the emphasis on straight lines and right angles in a landscape that naturally resists them? Some researchers suggest that these central mounds served as ritual or political hubs, places where authority was expressed not through walls but through scale and symmetry. The careful layout may have reinforced social order, with geometry acting as a visible expression of balance and control in an otherwise unpredictable environment. More speculative ideas take this further. Could the alignment of causeways reflect cosmological beliefs? In other parts of the ancient world, orientation toward cardinal directions carried symbolic weight. While no definitive astronomical function has been proven here, the possibility remains open. Geometry can encode meaning as easily as it manages space. There is also the question of population. The scale of the earthworks suggests tens of thousands of people coordinated across the region. This challenges older assumptions about Amazonian societies and raises deeper questions about how complex systems can exist without stone cities, metallurgy, or written records. What knowledge was required to design landscapes on this scale? How were plans communicated, maintained, and remembered? And how much of that knowledge vanished when the system itself collapsed, likely under pressure from climate shifts, social change, or later external disruptions? Like Gunung Padang and Tel Qaramel before it, the Qaramel earthworks occupy an uncomfortable space in the story of human development. They are neither primitive nor fully understood. They suggest mathematical thinking without formal mathematics, urban planning without cities as we define them, and permanence built from materials meant to return to the earth. Today, much of this landscape is still unexplored. Forest regrowth hides patterns that LiDAR only begins to reveal. Each new scan uncovers more shapes, more connections, more questions. The ground itself becomes a kind of archive, one that records intention through distance, angle, and repetition rather than text. As we trace these lines across the Amazonian plains, we are left to wonder, how many other engineered worlds lie hidden beneath assumptions of emptiness, waiting for us to learn how to read the mathematics written quietly into the land? As the engineered landscapes of the Amazon fade back into forest, lines and angles slowly dissolving into soil and memory, the journey turns again, toward a hill that has already reshaped how we think about the deep past. Here, the mystery is not spread across plains or hidden beneath vegetation, but buried deliberately beneath stone and earth, as if meant to be forgotten. Göbekli Tepe rises from the rolling limestone plateau of southeastern Anatolia, its pale surface catching the light above a dry, wind-shaped horizon. At first glance, it appears modest, a rounded mound, its contours softened by time. But excavation has revealed something extraordinary. Massive T-shaped stone pillars, carved with animals and abstract symbols, arranged into circular enclosures with unmistakable precision. These visible structures alone, dated to around 9,600 to 8,000 BC, have already forced a reconsideration of when monumental architecture began. Yet what draws quiet attention now lies beneath them. Below the exposed circles of Göbekli Tepe is a layered subsurface, compressed fills, earlier construction phases, and anomalies detected through geophysical surveys. The mound itself is largely artificial, composed not only of natural sediment, but of intentionally deposited material. Stone fragments, tools, and debris were carefully packed around standing pillars, sealing entire enclosures from view. This act of burial appears purposeful, repeated, and systematic. Why would a society capable of carving and erecting stones weighing several tons choose to entomb its own monuments? Mainstream archaeology suggests a practical explanation. As rituals changed or social structures evolved, older enclosures may have lost relevance. Rather than dismantling them, builders filled the spaces in, creating stable platforms for new constructions above. In this view, Göbekli Tepe represents a long-term ritual center, rebuilt and reshaped across centuries by mobile hunter-gatherer groups responding to shifting needs. But the stratigraphy tells a more complex story. Subsurface scans indicate that only a small percentage of Göbekli Tepe has been excavated. Beneath known enclosures lie deeper layers, possibly older structures, following similar circular plans. Some anomalies suggest additional pillars still standing underground, their shapes consistent with those already uncovered. If confirmed, this would imply that the site's visible monuments are only the latest chapter in a much longer architectural sequence. This raises a difficult question. How far back does the planning of Göbekli Tepe truly extend? The precision of the site is striking. Pillars are placed at consistent distances, often facing inward toward a central pair. The enclosures follow near-perfect circular or oval geometries, despite being carved without metal tools. Some researchers have noted proportional relationships between structures, ratios that hint at intentional measurement rather than approximation. While no formal mathematical system has been identified, the repetition of scale and spacing suggests shared rules, understood and maintained over generations. The subsurface layers complicate this further. If earlier enclosures exist below, then the geometry may not be a single invention, but a tradition, one that evolved while preserving core principles. Each buried circle could represent not abandonment, but continuity concealed beneath renewal. More speculative interpretations begin here. Some propose that the deliberate burial was symbolic, an act of closure or transformation. Covering a structure may have marked the end of a ritual cycle, sealing its power or memory into the earth. In many cultures, burial is not destruction, but transition. Could Göbekli Tepe's subsurface layers represent chapters of belief, each one layered carefully atop the last? Others wonder whether the mound was designed from the beginning to grow, an architecture of accumulation where depth itself carried meaning. If so, the unseen layers are not accidental remnants, but integral components of the site's function. What was hidden may have mattered as much as what was displayed. There are also unanswered questions about labor and knowledge. Constructing Göbekli Tepe required quarrying, transport, carving, and coordination on a scale not typically associated with pre-agricultural societies. Doing this repeatedly, across multiple layers, implies long-term planning and shared understanding. The subsurface suggests that this was not a brief experiment, but a sustained commitment. What sustained it? The lack of domestic structures nearby remains puzzling. Göbekli Tepe does not appear to be a village or settlement. Instead, it stands apart, a destination. If so, the buried layers may represent generations of visitors returning to the same place, guided by memory rather than maps, following layouts preserved through oral tradition and ritual practice. Geophysical surveys continue to reveal hints without answers. Linear features, circular voids, and dense stone concentrations appear beyond the excavated zones. Each anomaly suggests more beneath the surface, but excavation proceeds slowly, constrained by preservation concerns and the sheer scale of the site. As with the Kasarabe earthworks and the towers of Tel Qaramel, Göbekli Tepe resists simple categorization. It shows geometry without writing, coordination without cities, and monumentality without agriculture as we typically define it. Its subsurface layers deepen the mystery, suggesting that what we see is only a fraction of what was built, and perhaps only a fraction of what was meant to be understood. Standing above this buried architecture, one cannot help but wonder, how many intentional designs lie hidden below our current horizon of evidence? And how much of early human knowledge remains sealed beneath layers we have only just begun to uncover? As the buried circles of Göbekli Tepe recede into the earth, layer upon layer of stone sealed with intention, the journey turns once more, this time toward the western edge of the Mediterranean. Here, the mystery rises not from hidden depths, but from an unexpected form standing alone in an open plain, as if misplaced in both time and geography. In northern Sardinia, near the city of Sassari, Monte de Gedi emerges quietly from the landscape. At first glance, it resembles a low hill shaped by erosion, but as one draws closer, its geometry becomes impossible to ignore. A massive stone platform ascends in stepped layers, crowned by a flat summit. A long, straight ramp leads upward, guiding the eye and the body toward the top. In a region better known for Nuragic towers and Bronze Age settlements, this structure feels anomalous. It looks less like a European monument and more like something from ancient Mesopotamia. Monte de Gedi is often described as a pre-Ziggurat, a term that captures both its form and the uncertainty surrounding it. Excavations conducted in the mid-20th century revealed that the site was constructed in multiple phases, beginning around the late 4th millennium BC. The earliest version appears to have been a low platform, built from stone and earth, carefully leveled and oriented. Later, this structure was expanded, enlarged, and reshaped into the stepped monument visible today. The builders did not simply add height. They redefined the geometry, reinforcing the platform and extending the ramp with deliberate precision. The alignment of Monte de Gedi is striking. The ramp runs in a straight line, its orientation suggesting intentional planning rather than convenience. The edges of the platform are clean and angular, the summit flattened with care. This was not a mound formed gradually through habitation debris. It was architecture, conceived and executed with purpose. Mainstream archaeology interprets Monte Dakoti as a ritual altar or ceremonial platform. Artifacts found nearby, stone tools, pottery fragments, animal bones, suggest repeated use over generations. Some remains indicate ritual sacrifice, possibly involving livestock. In this view, the structure functioned as a sacred stage, elevating ceremonies above the surrounding land, creating a physical and symbolic separation between the ordinary and the sacred. Yet the form continues to provoke deeper questions. Why build such a structure here, in Sardinia, when nothing quite like it exists elsewhere in prehistoric Europe? Why adopt a stepped, ramped design so closely associated, at least visually, with Near Eastern ziggurats, despite the absence of direct evidence for contact? The resemblance may be coincidental. Stepped platforms are structurally efficient, and ramps provide practical access to elevated spaces. Geometry, once again, may reflect function rather than symbolism. And yet the similarities linger, inviting comparison without offering resolution. Monte Dakoti also shows signs of careful measurement. The platform's proportions appear balanced, its angles consistent. While no mathematical texts or markings exist, the builders clearly understood how to create level surfaces and stable slopes, skills that require planning and shared knowledge. The ramp, in particular, implies processional movement, guiding participants along a fixed path, framing experience through architecture. Some researchers have suggested that the site held astronomical significance. Nearby standing stones and the orientation of the structure have prompted speculation about alignments with solar or lunar events. These ideas remain unproven but not implausible. Across the ancient world, ritual platforms often intersected with sky observation, using geometry to connect Earth and cosmos. Other interpretations move further into speculation. Could Monte Dakoti represent a cultural memory, an architectural echo of ideas carried across the Mediterranean through migration or long-distance contact? Sardinia sits at a crossroads of sea routes, and while definitive evidence of influence from Mesopotamia is lacking, the island was not isolated. Knowledge can travel without leaving clear traces. There is also the question of what no longer exists. The summit of Monte Dakoti is bare today, but it may once have supported wooden structures, altars, or symbolic objects that have long since vanished. If so, the stone platform is only the foundation of a more complex ritual environment. What meanings were enacted here, elevated above the plain, framed by geometry and movement? The site's history adds another layer of mystery. After centuries of use, Monte Dakoti appears to have been abandoned. Later, cultures in Sardinia did not continue building in this style. The tradition ended, leaving behind a singular monument without clear descendants. Unlike Göbekli Tepe, which was deliberately buried, Monte Dakoti was left exposed, weathered, altered, and partially dismantled over time. Why was it abandoned? Did beliefs change? Did populations move? Or did the knowledge required to build and use such a structure simply fade, unrecorded? Modern restoration has stabilized the site, but much remains uncertain. Large areas around Monte Dakoti are still unexplored. Subsurface features, if present, may yet be revealed. As with so many of the sites we have encountered, the visible structure may represent only a fragment of a broader system, ritual, social, or symbolic, that once extended beyond what survives. Monte Dakoti stands today as a quiet contradiction. It is both familiar and alien, grounded in stone yet detached from clear narrative. Its geometry speaks of intention, its isolation of loss. And as the Mediterranean sun casts long shadows across its ramp and platform, the question remains unresolved. Was this monument an isolated experiment, or a remnant of a shared architectural language whose other words have been erased by time. As the solitary platform of Monte de Gedi lingers in the mind, its ramp rising toward a sky that once framed forgotten rituals, the journey shifts again, southward, into a landscape where geometry is not raised high but pressed quietly into the ground. Here, meaning is not immediately visible. It waits beneath sand and silence. Deep in the Nubian desert of southern Egypt lies Nabta Playa, a broad, shallow basin that today appears empty and unforgiving. The wind moves freely across its surface, carrying fine grains of sand that blur the horizon. There are no permanent structures rising above the plain, no monuments announcing themselves from a distance. And yet, this desolate place was once transformed by water and by human intention. Thousands of years ago, during periods of stronger monsoon rains, Nabta Playa filled seasonally with lakes and grasslands. What is now desert became a gathering place for nomadic pastoral groups, drawn by water, grazing land, and predictability in an otherwise uncertain environment. It is here, amid shifting climates and temporary abundance, that one of the earliest known expressions of measured space and alignment appears. At first, the discoveries seemed modest: scattered stones, small arrangements, shallow pits. But closer examination revealed patterns, careful placements that resisted randomness. Stone circles, aligned slabs, and rows of megaliths emerged from beneath the sand, some visible on the surface, others deliberately buried. These were not casual markers. They were positioned with precision. Radiocarbon dating places much of this activity between roughly 6,000 and 4,000 BC, long before dynastic Egypt and well before monumental stone architecture along the Nile. The people of Nabta Playa were not urban builders. They left no cities, no writing, no grand temples. Yet the geometry of their constructions suggests planning that extended beyond immediate survival. One of the most discussed features at Nabta Playa is a small stone circle, sometimes described as one of the world's earliest known calendrical devices. Several upright stones appear to align with the sunrise at the summer solstice, a moment of immense importance in a seasonal landscape. The arrival of summer rains determined whether life would return to the basin or retreat once more into arid uncertainty. Mainstream archaeology interprets these alignments cautiously. The stones may have served as seasonal markers, helping pastoral groups anticipate environmental change. In this context, the geometry is practical, rooted in observation rather than abstraction. Watching the sky, marking repetition, and encoding it into space would have been a powerful tool for communities dependent on timing and movement. But the surface features are only part of the story. Beneath the sand lie buried alignments, rows of stones placed vertically into the ground, some weighing several tons. These megaliths were not meant to be seen continuously. They were embedded, anchored, and in some cases deliberately covered. Their placement suggests linear patterns, orientations that may correspond to cardinal directions or celestial events, though interpretations vary. Why place such effort into stones that would remain largely hidden? One explanation is structural. Buried stones can stabilize markers, prevent movement, or serve as foundations for surface features that no longer survive. Another possibility is symbolic. In many cultures, what is placed underground carries weight precisely because it is unseen, acting as a root, an anchor, or a boundary between worlds. The underground alignments of Nabta Playa complicate simple narratives. They suggest forethought not only in horizontal space, but in depth. This implies an understanding of three-dimensional planning, where meaning operates above and below the surface simultaneously. Some researchers have noted that certain alignments appear to correspond with stellar positions, including stars associated with what would later become central to Egyptian cosmology. These ideas remain speculative, and no consensus exists. The risk of projecting later belief systems backward is well understood. Still, the possibility raises a quiet but persistent question: how much astronomical knowledge existed before it was ever written down? What we do know is that Nabta Playa reflects repeated use over long periods. The site was revisited, modified, and remembered. Stones were repositioned, new features added, old ones respected. This continuity suggests shared knowledge, rules about placement, orientation, and perhaps proportion, passed orally across generations. The mathematics here is not explicit, but it is implied. Aligning stones to solar events requires careful observation and consistency. Creating straight lines across open terrain demands reference points and correction. Maintaining alignment over years means understanding deviation and return. These are not accidents, they are practices. More speculative interpretations consider Nabta Playa as a proto-ritual landscape, a place where early cosmology, social order, and environment intersected. The act of marking time and direction may have reinforced group identity, linking survival to shared observation of the sky. Geometry, in this sense, becomes language. And yet, like Monte de Gedi, Nabta Playa was eventually abandoned. As the climate shifted and monsoons weakened, the lakes dried up. The basin lost its reliability. The people moved on, carrying their knowledge elsewhere, perhaps toward the Nile, where permanent water reshaped human possibility. Whether ideas from Nabta Playa traveled with them remains an open question, debated but unresolved. What remains today is fragmentary. Many stones have been removed or reburied for preservation. The alignments are incomplete, their full patterns difficult to reconstruct. The underground features, in particular, hint at systems we may never fully map without disturbing what has survived for millennia. Standing in the desert now, it is hard to imagine the careful observation, the repeated measurement, the quiet intention that once shaped this place. The wind erases footprints almost instantly. And yet, beneath the sand, the stones remain, still aligned, still waiting. If early societies were already embedding mathematics into the land, not in numbers but in orientation and depth, what other knowledge was practiced here without ever being recorded, and how much of it still lies hidden just below the surface in places we have learned to overlook? As the desert winds of Nabta Playa fade into memory, stones aligned to skies that no longer bring rain, the journey continues eastward across the Red Sea and into the Horn of Africa. Here, geometry is neither buried beneath sand nor raised upon ramps, but stretched across the land itself, traced in stone on a scale that quietly resists easy explanation. In eastern Ethiopia, near the ancient city of Harla, the landscape opens into rolling highlands scattered with dark volcanic rock. Acacia trees punctuate the terrain, and paths wind through fields that have supported human movement for thousands of years. At first, nothing appears unusual, but as one looks closer, patterns begin to surface. Long lines of stones, circular enclosures, carefully defined boundaries that repeat again and again across the countryside. These are the Harla megalithic enclosures. From the ground, they feel understated. Low stone walls form circles, ovals, and elongated shapes, some enclosing open space, others linked together in chains that extend across ridges and valleys. Individual enclosures vary in size, but many follow consistent proportions. The stones themselves are unworked, yet deliberately placed, stacked without mortar, balanced through careful selection rather than force. Archaeological research suggests that these structures span a wide range of dates, from roughly the late 1st millennium BC through the early 2nd millennium AD. This long period of construction and reuse complicates interpretation. The enclosures were not the product of a single moment or culture, but of repeated engagement with the same forms, the same spaces, the same logic of placement. Mainstream explanations tend toward the practical. Many of the enclosures are thought to have served as burial sites, territorial markers, or pastoral features, corrals for livestock, boundaries between groups, or memorials for the dead. In this view, the geometry reflects function. Circles are efficient for containment. Lines are effective for division. Repetition arises naturally from utility. Yet, as with so many of the sites encountered on this journey, utility alone does not answer every question. Why do some enclosures appear aligned along shared axes, stretching across uneven terrain with little deviation? Why are certain shapes repeated with such consistency, even when environmental conditions change? And why do some structures seem oversized for purely functional use, enclosing spaces far larger than necessary for animals or individual burials? The scale of the Harla megalithic landscape is difficult to grasp without distance. From elevated vantage points, the enclosures form networks, patterns that only emerge when viewed as a whole. This suggests planning beyond the individual structure, a shared understanding of space that extended across communities and generations. The mathematics here is subtle, embedded in spacing and repetition rather than overt calculation. Distances between enclosures often fall within similar ranges. Curvatures are maintained across sites. Angles where lines intersect appear intentional rather than incidental. While no measuring tools have been found, the results imply methods for maintaining proportion, techniques perhaps as simple as pacing, chords, or sightlines, refined over time. Some researchers have suggested that the enclosures reflect social organization mapped onto the land. Each circle or compound may have represented a lineage, a clan, or a ceremonial unit, with geometry serving as a visual language of belonging and separation. In this interpretation, the landscape itself becomes a record of relationships, structured through repeated forms. Others look beyond the social and toward the symbolic. In many cultures, circular enclosures carry cosmological meaning, representing cycles, continuity, or the boundary between worlds. The act of enclosing space can be as much about definition as defense. Could the Harla enclosures have marked ritual ground, places where movement was guided, restricted, or transformed? There are also unresolved questions about orientation. While not all enclosures align with cardinal directions, clusters sometimes share common directional emphasis. Whether this reflects environmental adaptation, inherited convention, or something more abstract remains uncertain. As at Nabta Playa, the possibility of astronomical awareness is raised cautiously, noted but not confirmed. More speculative theories explore the idea of Harla as a long-term ceremonial landscape, one that evolved as beliefs shifted but core spatial principles endured. In this view, geometry becomes tradition, a set of rules remembered not through writing but through repetition. Each new enclosure reinforces an old pattern, preserving knowledge through action rather than record. What complicates interpretation further is the relative silence of historical sources. Unlike later urban centers in the region, Harla's megalithic builders left no inscriptions explaining purpose or meaning. Oral traditions speak of ancient peoples and lost cities, but these accounts blur history and memory. Archaeology must rely instead on stone, spacing, and context. Excavations have been limited, and much of the landscape remains undocumented. Vegetation obscures features. Modern development alters terrain. Each season of research reveals new alignments, new clusters, extending the known network outward. The more that is mapped, the clearer it becomes that this was not a marginal activity, but a sustained one. The Harla enclosures also sit at a crossroads, geographically and culturally. Eastern Ethiopia has long been a corridor for movement between Africa, Arabia, and the wider Indian Ocean world. Ideas travel along such routes, often faster than material goods. While there is no direct evidence linking Harla's geometry to distant traditions, the possibility of shared concepts of space, boundary, and order cannot be dismissed. As with Monte da Gedi and Göbekli Tepe, the question is not whether these builders possessed mathematics in a modern sense, but how they practiced precision without formal notation. The land itself may have been the medium, measured by walking, by sight, by memory. Geometry lived not on parchment, but in movement and stone. Today, standing among the Harla megaliths, the experience is quiet. There is no single focal monument, no central tower or platform. Instead, meaning is distributed, spread across the landscape, waiting to be noticed. The enclosures do not demand attention, they reward patience. And so the mystery remains open. Were these stones simply tools of daily life, refined through repetition? Or do they record a deeper system of order, one that shaped how people understood space, identity, and continuity across centuries? If entire landscapes can be organized through rules we no longer recognize, how many other patterns lie hidden in plain sight, waiting for us to learn how to read them again? As the stone networks of Harla stretch quietly across the Ethiopian highlands, geometry dispersed into landscape rather than gathered into a single monument, the journey continues westward, across oceans and centuries, to a place where order takes on a sharper edge. Here, geometry is not implied or suggested. It is imposed. Deep within the lowland forests of northern Guatemala, near the shores of Lake Petén-Itzá, lies Nixtun-Ch'ich. From above, the site reveals itself with startling clarity. Straight lines cut through the jungle, angles repeat with near-mechanical consistency. Platforms, plazas, and causeways lock together in a rigid pattern that feels almost out of place in the ancient world. This is not the organic sprawl commonly associated with Maya cities. This is a grid. On the ground, Nixtun-Ch'ich is quieter, more subtle. Vegetation softens edges. Earth-covered structures rise only a few meters high. But beneath the roots and soil, the plan remains intact, one of the earliest known examples of a fully gridded city in the Americas. Archaeological evidence suggests that Nixtun-Ch'ich was founded around 600 to 300 BC, during the Middle Preclassic period of Maya civilization. At this early stage, Maya settlements were typically arranged around natural features, growing gradually rather than following strict plans. Nixtun-Ch'ich breaks from that pattern entirely. The city is organized around long, straight causeways that run north to south, intersected by evenly spaced east to west platforms. Residential areas, ceremonial spaces, and public plazas were all fitted into this rigid framework. Even the site's central pyramid conforms to the grid, aligned precisely with the surrounding structures. This level of planning suggests forethought on a scale rarely seen so early. The grid would have required surveying, measurement, and coordination before construction began. Once established, it would have constrained growth, forcing builders and inhabitants to adapt to the plan rather than reshape it organically. Mainstream interpretations describe Nixtun-Ch'ich as an experiment, an early attempt at centralized urban planning. The grid may have reflected political authority, imposed by elites seeking control through spatial order. Straight lines and right angles leave little room for improvisation. They regulate movement, visibility, and access. In this view, geometry becomes governance. The layout directs how people move through space, where they gather, and what they see. Long avenues frame sight lines toward ceremonial centers. Repetition reinforces hierarchy. The city itself becomes a tool, shaping behavior through design rather than decree. But this raises an immediate question. Why here, and why then? Nixtun-Ch'ich appears to have been occupied for only a few centuries. Later, Maya cities, great centers like Tikal or Calakmul, returned to more flexible layouts, blending geometry with topography. The strict grid was not widely adopted. It emerged, fully formed, and then faded. Was the grid a success that no one chose to repeat, or a failure abandoned quietly? The precision of Nixtun-Ch'ich is difficult to dismiss as purely functional. The consistency of spacing, the alignment of structures, and the apparent lack of adaptation to terrain all suggest adherence to an abstract ideal. The city was not shaped by the land. The land was reshaped to fit the plan. Some researchers note that the grid aligns closely with cardinal directions. This opens the possibility of cosmological significance. In Maya thought, direction was deeply symbolic: north, south, east, and west associated with colors, deities, and aspects of time. Organizing a city along these axes could have embedded cosmology directly into daily life. In this interpretation, Nixtun-Ch'ich was not merely efficient, it was meaningful. Living within the grid may have been a way of inhabiting an ordered universe, where movement through space echoed movement through myth and ritual. More speculative ideas take this further. Some propose that the grid reflects influence from outside the Maya lowlands, ideas transmitted through trade or migration from other regions experimenting with planned settlements. Others suggest it represents a lost tradition, one that briefly surfaced before being replaced by more adaptive models. There is also the human question. What was it like to live in a city with no curves? To walk the same straight paths day after day, framed by repetition and predictability? Did the grid offer clarity and stability, or did it feel restrictive, imposed rather than grown? Archaeological remains provide few answers. Household structures conform to the plan, but artifacts suggest everyday life continued much as elsewhere. The grid shaped space, but not necessarily culture in obvious ways. And yet, the decision to build this way had consequences. Once laid down, the grid could not easily evolve. Expansion meant repetition or rupture. Eventually, Nixtun-Ch'ich was abandoned. The reasons remain uncertain. Environmental change, political shifts, or competition from neighboring centers may have played a role. Or perhaps the rigidity of the plan itself limited the city's resilience. Geometry, so powerful in establishing order, may have become a constraint in a world that demanded flexibility. As with many sites in this exploration, what lies beneath Nixtun-Ch'ich complicates the story. Subsurface mapping indicates earlier phases of construction beneath the visible grid, suggesting that the decision to impose order was deliberate, replacing something less formal. The grid was not inherited, it was chosen. Why that choice was made remains unresolved. Nixtun-Ch'ich stands as a quiet outlier in ancient urban history. It shows that mathematical precision and abstract planning were not late developments, nor confined to a single region. They emerged, independently, in different forms, sometimes embraced, sometimes abandoned. Walking these straight avenues today, softened by jungle growth, one senses both ambition and restraint. The city feels frozen in intention, a moment where human thought attempted to impose perfect order on a complex world. And that leaves a final question lingering in the air. When ancient builders chose geometry over adaptability, were they reaching for harmony or testing the limits of control in a landscape that would ultimately reclaim its own design? As the straight avenues of Nixtun-Ch'ich dissolve back into jungle, order imposed, then quietly reclaimed, the journey continues south along the spine of the Americas to a landscape where geometry takes on mass and silence. Here, planning is not etched into a grid, but stacked into monumental stillness, rising from a desert valley that has watched civilizations come and go. In Peru's Casma Valley, between the Pacific coast and the foothills of the Andes, Sechin Alto dominates the plain. From a distance, it appears less like a ruin and more like a natural formation, broad earthen walls stepping upward in heavy tiers. But as one approaches, scale becomes unmistakable. Sechin Alto is immense, sprawling, deliberate. It is one of the largest stone and earth complexes of the ancient world, built long before empires, writing, or metal tools reshaped history. The structure stretches across more than 300 hectares. Massive perimeter walls define its boundaries. At the center rises a towering platform mound, its layered terraces arranged with careful symmetry. Stone blocks and compacted earth form straight edges and measured rises, creating a sense of imposed order in a landscape otherwise shaped by wind and seasonal rivers. Radiocarbon dating places Sechin Alto's construction between roughly 1,800 and 900 BC, making it contemporaneous with some of the earliest monumental traditions in the Andes. It belongs to a cluster of sites, Las Haldas, Sechin Bajo, Cerro Sechin, that together suggest a dense and organized cultural presence in the valley. But Sechin Alto stands apart for its sheer scale and restraint. There are no towering statues here, no elaborate reliefs dominating the main complex. Instead, meaning seems embedded in proportion and repetition. Walls extend in long, straight lines. Platforms rise in measured steps. Space is divided and controlled, not ornamented. Mainstream archaeology interprets Sechin Alto as a ceremonial and administrative center. The massive enclosure walls may have regulated access, guiding movement inward toward ritual spaces. The central platform likely served as a focal point, an elevated stage for ceremonies, gatherings, or displays of authority. In this reading, the architecture reflects emerging social hierarchy, expressed through control of space and labor. The mathematics of Sechin Alto are not overt, but they are persistent. Constructing terraces of this scale requires planning, calculating load, slope, and stability. The alignment of walls suggests shared reference points. The symmetry of the central mound implies intention rather than accumulation. Even the decision to build outward, enclosing vast open areas, speaks to an understanding of space as something to be defined, not merely occupied. Yet for all this effort, Sechin Alto remains strangely quiet. Unlike nearby Cerro Sechin, with its carved stone panels depicting violence and ritual, Sechin Alto offers little narrative imagery. The site communicates through form alone. This absence invites interpretation, but resists certainty. Why build something so large, so ordered, and yet so visually restrained? One possibility is that Sechin Alto was designed to be experienced through movement rather than imagery. Processions may have followed prescribed paths, ascending terraces in sequence. Geometry would have guided perception, what could be seen, when, and from where. In this sense, the architecture itself becomes a ritual script, unfolding through space and elevation. Another interpretation considers the relationship between Sechin Alto and its environment. The Chasma Valley is arid, dependent on river management and seasonal predictability. Large-scale construction here may reflect coordinated labor tied to agricultural cycles. The complex could have functioned as a center for organizing irrigation, storage, and redistribution, its size a reflection of collective effort rather than individual power. Still, questions linger. Excavations suggest that Sechin Alto was built relatively quickly, implying centralized planning and authority. But evidence of permanent residential occupation within the main complex is limited. Like Göbekli Tepe, it may have been a destination rather than a home, a place people gathered for specific purposes, then dispersed. If so, what drew them here? More speculative theories explore the idea of Sechin Alto as a symbolic landscape, a place where geometry reinforced cosmology. In Andean thought, mountains, platforms, and layered space often carried spiritual meaning. Ascending a structure could mirror ascent through worlds or states of being. The careful spacing of terraces may have encoded concepts of balance, order, or transition. As with many ancient complexes, the question of knowledge arises. How were these plans conceived and transmitted? There is no evidence of writing. Measurement would have relied on body-based units, cords, sight lines, methods simple in appearance but powerful in consistency. Over time, such practices can produce remarkable precision. What remains unresolved is intent. Was Sechin Alto built to last, or to be used and abandoned? Evidence suggests phases of construction and modification, but also periods of decline. Eventually, the complex fell silent. Wind filled its spaces. Sand softened its edges. Later cultures did not rebuild it on the same scale. Why did this monumental tradition end? Climate shifts may have played a role. Social structures may have changed. Or the very systems that enabled such coordination may have become unsustainable. Geometry, once again, may have been both strength and limitation. Today, Sechin Alto stands exposed beneath an open sky, its vastness difficult to comprehend without aerial perspective. From above, its order becomes clear. Lines, terraces, enclosures arranged with purpose. From the ground, it feels almost abstract, its meaning diffused across distance and height. Like Nixtun-Ch'ich, it represents a moment when humans chose structure over improvisation, permanence over flexibility. But unlike the gridded city, Sechin Alto does not constrain daily life. It frames something larger: ritual, authority, memory, without explaining itself. And so the stone complex remains, massive and silent, offering no inscriptions, only scale and proportion. If early societies were capable of organizing labor and landscape on this level, guided by principles we can only partially reconstruct, what other systems of knowledge once shaped the world? And how many of them are still hidden within forms we have yet to fully understand? As the vast terraces and platforms of Sechin Alto fade into memory, stone and earth aligned with monumental precision, the journey moves farther north along the Pacific coast of South America, toward a place where geometry begins to speak in rhythm and repetition, tracing not only human ambition, but perhaps the earliest stirrings of urban complexity. Here, precision is layered into a core, compact but profoundly deliberate, an epicenter of activity that seems to predate and anticipate the structures that would follow. In the arid coastal plain of Peru's Huaura Valley, the site of Bandurria rises subtly from the desert landscape. To the casual observer, the mounds resemble irregular heaps of sand and stone, weathered by centuries of wind. But careful excavation reveals a far more intricate reality. Bandurria is a monumental city, its core, known as the Monumental Core, constructed with a deliberate plan, combining platforms, stairways, and plazas into a compact hub of ceremonial and social activity. Unlike Sechin Alto, which stretches across hundreds of hectares, Bandurria's monumental zone compresses order into a central nucleus, where geometry governs movement, sight lines, and experience. Radiocarbon dating places construction of Bandurria as early as 4,500 BC, making it one of the oldest known urban centers in the Americas. Its monumental core exhibits terraces rising in measured steps, plazas framed by rectilinear platforms, and a layout that is not random but clearly coordinated. Walls align with remarkable precision, and stairways connect levels in sequences that suggest careful spatial planning. Even at this early date, the builders of Bandurria were creating an ordered landscape, a controlled environment that mirrors social or ritual hierarchy in stone. Mainstream archaeology interprets the monumental core as a ceremonial center, likely serving both ritual and administrative functions. Large plazas may have accommodated gatherings, offerings, or communal events. Elevated platforms may have highlighted authority or religious practice. The precise arrangement of terraces and stairways indicates forethought. Space was designed, not simply occupied. Geometry, in this reading, is practical. a tool for organization and control within an emergent urban system. Yet the more we examine Bandurria, the more questions arise. Why did early builders invest such effort into precision at a time when agriculture and urban infrastructure were still developing? Why concentrate so much labor and planning into a core area rather than spreading activity across the landscape? And what guided the choice of angles, spacing, and height? These questions hint at knowledge embedded not in written records, but in measurement, observation, and repeated practice. The monumental core displays a remarkable consistency. Platforms and terraces maintain relative proportions, stairways follow regular gradients, and the orientation of structures appears deliberate. While no tools for measurement survive, the effect suggests a shared understanding of geometry, one encoded into action rather than text. Such precision implies that the builders were not improvising. They were applying principles over multiple generations, refining and replicating forms with care. Some researchers have suggested astronomical considerations. Certain platforms and open spaces may have been aligned with solar or lunar events, particularly solstices, reflecting a concern with time and seasonal cycles. While evidence remains debated, the possibility echoes patterns observed at other early sites, like Nabta Playa, where celestial alignment intersects with human organization. If these alignments were intentional, the monumental core becomes more than an administrative or ritual space. It becomes a tool for understanding the heavens. More speculative interpretations explore Bandurria's monumental core as a kind of early proto-urban laboratory. The compact arrangement suggests a concentration of social, economic, and ritual life, testing the possibilities of community organization. The terraces and platforms may have codified hierarchy, movement, and interaction, physical geometry shaping social behavior. In this sense, mathematics is expressed in placement, spacing, and proportion, not in written formulae. The materials themselves reinforce the sense of order. Stone and compacted earth were chosen and arranged carefully. Platforms rise in regular courses, suggesting not haphazard piling, but conscious layering. Even the smallest alignments of stones suggest observation of angle, spacing, and balance. The monumental core communicates through its form, demonstrating knowledge of structural integrity alongside spatial logic. Yet much remains obscured. Only a fraction of Bandurria has been fully excavated. Subsurface surveys hint at additional structures, possibly older phases beneath the visible terraces. If these remain intact, they could reveal a longer sequence of design, one that extends the understanding of early Andean mathematics, architecture, and social coordination. The monumental core may not be the beginning. It may be the most visible stage of a deeper, older tradition of planning and measurement. The comparison with later Andean centers is striking. Bandurria predates monumental structures at Caral and other late Preceramic sites, suggesting that the practice of organizing space with precision was not incidental. It emerges independently, a choice rather than an inheritance, a moment where human thought intersected with the landscape in measurable ways. Even today, the monumental core conveys a sense of intentionality that transcends its age. Walking across the plazas, ascending terraces, or tracing the edges of platforms, one experiences the spatial logic embedded in the site. It is a quiet, disciplined geometry, a deliberate shaping of perception, movement, and hierarchy. Unlike sprawling cities, its compactness amplifies its presence. Geometry becomes tangible, guiding experience rather than merely enclosing it. And yet, the core remains enigmatic. We cannot fully know what rituals unfolded on these platforms, what knowledge informed the placement of each terrace, or what worldview the builders intended to manifest through stone and earth. Its design demonstrates comprehension of proportion, alignment, and order. But to what degree were these principles consciously mathematical, symbolic, or functional? Like Sechin Alto and Nixtun-Ch'ich, Bandurria challenges assumptions about the emergence of human complexity. Monumentality, planning, and precision appear far earlier than previously believed. Geometry, expressed through placement, proportion, and alignment, becomes a medium of organization and meaning. And as with so many ancient constructions, the monumental core prompts reflection on what was known, remembered, and perhaps deliberately hidden beneath centuries of sand and silence. Standing amid the terraces and stairways today, the monumental core of Bandurria conveys both achievement and mystery. It shows what humans are capable of when intention and observation converge, yet it leaves unanswered the deepest questions. How was this knowledge shared across generations? How many other principles of measurement, proportion, and urban design were practiced long before formal record-keeping? And what else remains buried beneath the plain, waiting to reveal the logic of civilizations we thought we only just began to understand? As the monumental terraces of Bandurria fade behind us, platforms and plazas aligned with deliberate precision, the journey turns once more, this time to the highlands of the Caucasus, where geometry and sound intersect in a way that challenges both perception and expectation. Here, the mystery is not contained in towering platforms or compact cores, but scattered across a plateau in quiet resonance, waiting to be felt as much as seen. In the remote Syunik province of southern Armenia, near the borderlands of ancient trade routes, lies Zorats. From a distance, the site resembles a natural scatter of stones across the steppe, but closer inspection reveals arrangement: lines, circles, and clusters of upright megaliths, some standing over 2 meters tall. Known colloquially as the Sound Stones, or Karahunch, the site extends across more than 3 hectares, each stone placed with an intent that has fascinated researchers for decades. Radiocarbon dating suggests that the site was first constructed around 3,500 to 3000 BC, making it roughly contemporaneous with some of the earliest megalithic traditions in Europe and the Middle East. Unlike the monumental architecture of Sechin Alto or the compact urbanism of Bandurria, Zorats does not dominate the landscape with sheer mass. Its power lies in alignment, spacing, and, intriguingly, acoustics. Walking among the stones, one notices immediately how sound behaves differently here. Some stones, when struck, emit clear, bell-like tones. Others produce muted vibrations. The variation is consistent enough to suggest that it was recognized and perhaps even intentionally selected. Could this have been an early form of sonic architecture, where geometry and resonance combined to produce experience beyond the visual? Mainstream archaeology interprets Zorats primarily as a ceremonial or burial site. Excavations have revealed circular stone settings and cyst graves, indicating ritual and mortuary activity. Some stones bear cup-shaped depressions, interpreted as libation basins or symbolic markers. The site's orientation also seems significant. Certain rows align roughly with celestial events, including solstices and lunar cycles. Yet none of these observations fully explains the consistency of sound across dozens of megaliths. The singing stones of Zorats suggest that early builders recognized resonance, timber, and stone as materials to be organized, not just for support, but for experience. To place a stone with attention to its sonic properties requires both observation and intention, a combination of empirical knowledge and cultural insight. Even more puzzling is the arrangement itself. Unlike the tightly gridded city of Nixtun-Ch'ich or the tiered platforms of Sechin Alto, the stones of Zorats occupy a sprawling semi-random pattern. Lines stretch across open ground, occasionally forming arcs or circles. Yet subtle proportional relationships are visible. Distances between stones fall within narrow ranges, angles recur, and clusters repeat motifs across the plateau. The pattern feels intentional without rigid constraint. Some researchers have proposed that Zorats functioned as an early astronomical observatory. Certain stones appear to mark the rising points of prominent stars or the trajectory of the sun and moon at key times of the year. In this interpretation, sound may have reinforced observation. Ritual or communal practices could have been accompanied by measured tones, signaling or codifying temporal knowledge. If correct, the site becomes more than a cemetery. It becomes a spatial and auditory map of time and cosmos. Speculative theories push further. Could the resonance of these stones have been part of ritual performance? Were ceremonies conducted with stone tones guiding movement, marking rhythm, or signaling participation? In many cultures, sound is a bridge between worlds, between the living and the dead, the earthly and the celestial. Zorats may have embedded both mathematics and experience into its layout. Distances, angles, and sonic properties calibrated for collective perception. The precision required to achieve this is striking. Selecting stones for size, material, and internal structure, then arranging them across a plateau to produce reproducible tones, implies observational sophistication. The builders would have needed not only aesthetic or ritual sensitivity, but practical knowledge, how to predict resonance, how to align clusters for both effect and visibility, and how to maintain relationships across space. Geometry here is inseparable from physics, inseparable. Yet the mystery deepens when considering what may lie unseen. Subsurface surveys hint at additional stones buried beneath the topsoil, and erosion may have altered the original positions of others. The site may have extended farther than currently documented, with alignments and acoustic relationships now partially lost. What we see today is only a fragment of a potentially larger system, one designed to interact with the senses in ways we can only partially reconstruct. Another enduring puzzle is the cultural context. Zorats predates many of the surrounding civilizations that later dominate historical narratives. The knowledge encoded here, mathematical, architectural, acoustic, seems advanced for a society without writing or centralized administration as we typically understand it. Was this specialized knowledge confined to a small priestly or ritual class, or was it shared among broader communities, embedded into cultural memory and practice? Modern visitors often experience Zorats quietly, struck by the subtle interplay of stone, space, and sound. The site resists conventional monumental awe. Its presence is contemplative, immersive, and elusive. Walking its lines, striking a stone, or listening to the ambient resonance reveals intentionality without explanation, a human design that predates our capacity to document it fully. Like the urban grids of Nixtun-Ch'ich or the massive terraces of Sechin Alto, Zorats demonstrates that early societies were capable of encoding sophisticated understanding into the environment. But here, mathematics intersects with experience in a way that is tactile and auditory. Geometry is not just visual, it resonates, literally and metaphorically. And yet, as with all sites in this exploration, questions remain. Were the sonic properties intentional or incidental? Did the arrangement of stones serve primarily astronomical, ritual, or social functions? How much knowledge of resonance and alignment has been lost to time? What patterns remain hidden beneath soil or obscured by centuries of wind and weather? Standing today amid the soundstones, one is struck by the quiet persistence of human curiosity and skill. The stones endure, shaped by hands that measured distance, observed celestial patterns, and perhaps even understood the subtleties of vibration. The site challenges assumptions about what early societies were capable of, reminding us that precision, planning, and perception can manifest in forms both subtle and profound. And so Zorats waits, a plateau of sound and stone, inviting reflection. Its geometry, its resonance, and its enduring alignment whisper across millennia, raising the ultimate question. If human knowledge can be encoded in stone, angle, and tone, how many other principles, mathematical, astronomical, or acoustic, remain hidden in places we have yet to uncover? As the resonant stones of Zorats fade into memory, upright, aligned, and singing across the Armenian plateau, the journey of mathematical precision takes us southward, across the Arabian Peninsula, to a land of ancient rivers and desert valleys. Here, human ingenuity is etched not in stone terraces or grids, but in the manipulation of water itself, where early engineering meets environmental mastery. In the arid highlands of what is now Yemen, near the modern city of Marib, lies one of the most remarkable feats of proto-engineering in the ancient world, the Marib Dam. Today, the dam appears as a series of earthen embankments, partially reconstructed in modern times, but archaeological evidence reveals a history stretching back to the early 1st millennium BC, and possibly earlier. Beneath the visible remnants lies the Proto-Engineering phase, a stage of experimentation, adaptation, and remarkable foresight that transformed human interaction with landscape and water. From a distance, the site blends with its surroundings. The embankments rise subtly from the plain, curving in gentle arcs. Dry riverbeds and terraces hint at water management, but the complexity is invisible until one steps closer. Here, channels, sluices, and stone foundations form a system designed to capture, store, and redirect seasonal floods from the Wadi Adhana. The scale is not immediately imposing, yet its precision is unmistakable. The geometry of embankments, the angles of diversion channels, and the carefully leveled terraces all reflect sophisticated understanding of both hydraulic principles and environmental behavior. The proto-engineering phase of the Marib Dam may have begun as early as 1000 BC, although some evidence suggests even earlier experimentation with smaller embankments and water channels. At this stage, builders were not yet constructing the monumental dam known from later Sabaean inscriptions. They were testing methods, adjusting gradients, and observing seasonal patterns. The aim was not only storage, but control. The capacity to modulate the flow of floodwaters, to protect settlements, and to irrigate fields over large distances. Mainstream archaeology interprets this phase as the practical foundation of Sabaean civilization. In a land where rainfall is erratic and rivers seasonal, the ability to manage water directly influenced social and political organization. Controlling irrigation meant controlling agriculture, population, and trade. Proto-engineering at Marib represents early centralization of knowledge, surveying, planning, and construction coordinated across generations. Yet there is more to this early phase than pure utility. The geometry of the embankments and channels suggests careful calculation. Curved lines follow predictable arcs, gradients are measured to fractions of a degree, and overflow channels are spaced at intervals that reflect careful observation of hydrodynamic behavior. In a landscape where survival depended on precision, miscalculations could mean famine or devastation. The builders were practicing applied mathematics in the form of terrain, water, and soil. Some researchers have speculated that the proto-engineering phase also included ritualized aspects. Water management in ancient Yemen was often imbued with spiritual significance. Wells, canals, and embankments were sometimes associated with offerings, ceremonies, or symbolic structures. The act of directing water may have represented not only technical mastery, but cultural authority, a physical manifestation of human influence over nature. The scale and coordination are striking. Proto-dams, smaller embankments, and trial channels would have required measurement, leveling, and careful placement. The construction techniques suggest communal labor organized under leadership capable of long-term planning. Yet the designs were adaptive, not rigid. Embankments were modified seasonally, channels rerouted, and flood patterns incorporated into successive iterations. Here, geometry is not imposed dogmatically. It is applied dynamically, in dialogue with the environment. In some ways, the Proto-Engineering phase at Marib resembles other early sites we have explored. Like Bandurria or Nixtun-Ch'ich, it reflects human capacity to impose order through measurement, proportion, and foresight. Yet, unlike stone platforms or grids, the medium is mutable. Earth and water are unpredictable. They resist control. Achieving consistent results required observation over decades, refinement over generations, and an intimate understanding of environmental behavior. Environmental questions abound. How much of this knowledge was formalized versus learned experientially? Did early engineers use standardized units of measurement, or did they rely on pacing, sightlines, and empirical rules? How were labor, planning, and seasonal observation coordinated without written manuals? The answers remain speculative, yet the evidence demonstrates remarkable competence and a proto-scientific mindset. Even the failures are instructive. Flooding occasionally breached early embankments, forcing reconstruction and adaptation. Layers of sediment and repair tell a story of experimentation, a dialogue between human ingenuity and the capricious desert environment. Each reconstruction phase encodes lessons learned, an early record of applied trial and error that would eventually culminate in the monumental Sabaean Dam. From a modern perspective, the Proto-Engineering phase of Marib illustrates something profound. Mathematics in practice, expressed not in texts, but in landscape. The angles of embankments, the intervals of channels, and the calculated rise and fall of terraces represent an understanding of proportion, measurement, and cause-effect relationships. This is applied knowledge, functional and aesthetic, embedded in the land itself. Yet mysteries remain. How much of the original proto-dam system is lost beneath centuries of sediment? Were there additional, smaller embankments that extended irrigation to more distant fields, now erased by time? How did early engineers transmit knowledge across generations without formalized notation? The answers are hidden, encoded in soil layers, water courses, and subtle gradients still readable only through careful study. Walking along the remnants of early embankments today, one senses both ingenuity and restraint. Unlike later monumental constructions, the Proto-Engineering phase is humble in scale, yet immense in conceptual ambition. It demonstrates human capacity to observe, predict, and shape the natural world while responding to its variability. Geometry here is functional, adaptive, and alive. And yet, the questions endure. Did the proto-engineers of Marib see their work purely as practical or as part of a larger cosmological or ritual framework? How many lessons, innovations, and measurements from this early phase influenced later Sabaean monumental architecture? And beyond the visible embankments, what hidden channels, foundations, or alignments still lie buried beneath the desert, preserving secrets of human ingenuity that we have yet to uncover? The Proto-Engineering phase at Marib reminds us that mathematical precision need not always be inscribed in stone or grids. It can flow with water, rise with earth, and emerge from observation, iteration, and patient experimentation. Here, ancient knowledge endures quietly, waiting for those willing to read the subtle geometry of a landscape shaped by one of humanity's earliest and most sophisticated collaborations with nature. As the engineered embankments of Marib fade into memory, the result of careful observation, proto-mathematical calculation, and patient human labor, the journey of measurement, proportion, and intent carries us northward across Central Asia. Here, the landscape is open, vast, and at first deceptively empty, yet upon closer inspection, it reveals traces of human order stretching across the steppe. The horizon is punctuated by low hills and gentle rises, but it is on the flat plains that one finds evidence of deliberate placement. Rings of stone, laid with precision, echoing patterns seen elsewhere, yet entirely unique to this region. In central Kazakhstan, across the semi-arid steppes, lie the Tasmola stone rings. These formations are scattered across hundreds of square kilometers, often isolated, yet occasionally clustered in loose networks. From the air, they are mesmerizing. Perfect circles, some with diameters reaching 30 meters, composed of upright stones carefully positioned in sequence. Some rings contain central cairns or small mounds. Others align with nearby topographical features, hinting at a deliberate orientation that remains largely unexplained. Archaeological investigation suggests that many of these stone rings date to the Bronze Age, roughly between 2000 and 700 BC. They were part of a broader cultural landscape in which nomadic communities moved across vast territories, herding animals and interacting with environmental rhythms dictated by seasons, rivers, and pastures. Yet the rings themselves are stationary, constructed with effort and precision that suggests significance beyond mere utility. Mainstream interpretations describe the Tasmola rings as burial sites or ritual monuments. Excavations in some rings have revealed human remains, often accompanied by pottery, metal objects, or simple tools. In this sense, the stones may have served as markers, memorializing the dead, defining sacred space, or guiding social interaction within the landscape. Yet the uniformity of shape, the repeated geometry, and the occasional alignment with celestial points suggest something more, an awareness of mathematics expressed in stone. Walking among the rings, one senses subtle intention. Stones vary in size, yet their spacing and placement follow discernible patterns. Some sequences suggest consideration of circumference and proportion. Others seem to acknowledge cardinal directions. Distances between rings in clustered networks often fall within consistent ranges. Whether these patterns reflect surveying methods, ritual codification, or both remains an open question. Speculative interpretations expand the mystery. Could the rings have been used to track lunar or solar cycles, much like stone observatories elsewhere? Did they serve as markers for seasonal grazing, guiding nomadic movements with geometric precision? Some researchers propose that the arrangement of rings across the steppe may have encoded information about resource management, migration, or social organization, a network of knowledge etched into the land without words. The construction of a single ring itself implies sophisticated observation. Aligning stones in a circle requires repeated measurement or pacing, careful attention to angles, and an understanding of symmetry. Reproducing these forms across generations demonstrates cultural continuity and shared methodology, suggesting that these communities valued spatial awareness and order. Even in the absence of monumental architecture, mathematics manifested here through placement, proportion, and intentionality. Orientation remains another enduring enigma. Several rings appear to align with solstitial sunrises or sunsets, though the evidence is not uniform. Could these alignments have provided temporal markers for agricultural cycles, ritual observances, or seasonal gatherings? If so, the Tasmola rings join a growing list of ancient sites where geometry and cosmology intersect, reinforcing the idea that early societies across the globe independently developed methods to measure, observe, and structure experience. Yet the rings resist simple interpretation. Unlike fixed urban grids or massive platforms, they are dispersed, often solitary. Unlike monumental dams or terraces, they do not convey labor in terms of mass, but in precision and intent. The scale of human effort is subtle, almost invisible, yet present in every carefully placed stone. Here, mathematics is quiet, encoded not in large-scale domination of terrain, but in the measured repetition and careful alignment of modest elements. The relationship between the rings and surrounding topography further deepens the mystery. Some rings sit near low hills, rivers, or depressions. Others occupy open plains. Their placement does not always correlate with immediate utility. Why build here and not there? Why maintain strict circularity when organic shapes might have sufficed? The answers remain speculative, yet they point toward an early conceptualization of space, an ability to abstract form and project order onto an open landscape. Subsurface surveys and excavations have revealed that some rings were not single-phase constructions. Stones may have been added, adjusted, or realigned over time. Central mounds or cairns suggest repeated interaction with the site, perhaps marking successive generations or events. This implies a cultural memory of geometry and placement, transmitted orally or through practice, ensuring continuity across centuries. The Tasmola rings also invite reflection on sensory experience. Walking through a ring, standing at its center, one perceives alignment and symmetry in subtle ways. From the center, outer stones frame horizons. From the perimeter, sightlines converge inward. Geometry structures perception, creating space that is both measured and experiential. The rings are not merely visual, they are spatial instruments, shaping how movement, attention, and ritual might have unfolded. Like other sites explored in this series, from the grids of Nixtun-Ch'ich to the sound stones of Zorats, the Tasmola rings illustrate the universality of human engagement with mathematics. Across continents and centuries, early societies translated observation into action, abstract thought into tangible form. Here, even nomadic or semi-nomadic people left enduring evidence of their understanding, codifying knowledge in stone, not text. Yet, much remains hidden. How many rings have eroded beneath soil and vegetation, leaving only fragments behind? How many subtle alignments or spatial patterns are invisible to the human eye today, only perceptible through aerial or geospatial analysis? And most profoundly, what cultural knowledge guided placement, proportion, and alignment? Knowledge now lost to time, encoded solely in geometry and memory? Standing among the Tasmola rings today, the steppe stretches endlessly in every direction. The stones endure, silent and measured, embodying knowledge, intention, and human engagement with space and landscape. Geometry, proportion, and perhaps even ritual resonance persist in forms that are both simple and extraordinary. And so the mystery remains. These circles of stone invite us to ask, if human societies could encode mathematics, orientation, and cosmology in dispersed rings across an open plain, what other systems of knowledge may lie hidden in landscapes we have yet to study? How many principles of order, measure, and rhythm remain embedded in earth and stone, waiting for patient observation to reveal them once more? As the silent rings of Tasmola recede behind us, etched across the Kazakh steppe in quiet geometry, our journey turns toward the East African coast, where mathematics manifests not in stone circles or platforms, but in the meticulous planning of a city rising from coral reefs and tidal sands. Here, precision meets adaptability, a human settlement designed to endure tides, climate, and centuries of occupation, yet still revealing an underlying order that hints at careful thought and applied measurement. On the densely vegetated coastline of Kenya, near the Indian Ocean, lie the ruins of Gedi, a coral stone city that flourished between roughly the 13th and 17th centuries A.D. Today, its ruins are evocative, partially collapsed walls, doorways framed with coral blocks, and foundations tracing streets and neighborhoods that hint at a sophisticated urban layout. From above, the city appears as a loose labyrinth of interconnected compounds, mosques, and public spaces, but beneath the apparent irregularity, patterns of planning and proportion emerge. Gedi is built entirely from coral rag, quarried locally and assembled with remarkable skill. Walls are straight, corners are squared, and compounds are organized into clusters. Streets run at regular intervals, suggesting intentional spacing. Some researchers note that the orientation of streets and public buildings reflects careful attention to prevailing winds, topography, and access to water sources. This is a city where survival, comfort, and aesthetics are intertwined with geometry. The planning of Gedi demonstrates more than just practicality. Residential compounds are arranged in quadrilateral layouts, often surrounding small courtyards. Public spaces, including mosques and assembly areas, occupy central positions relative to these clusters. Even the smaller passageways and alleyways appear measured, balancing access, privacy, and circulation. Such organization implies forethought. Builders imposed order on the landscape rather than responding randomly to it. Mainstream archaeological interpretations emphasize Gedi's role as a trade hub within the Swahili Coast Network. Its location near deep water channels allowed access to maritime trade, linking Africa to Arabia, India, and beyond. The city's layout may have facilitated commercial activity, guiding movement of goods, people, and resources. Yet while commerce explains function, it does not entirely account for the precision and consistency of spatial organization. There is a mathematical quality embedded in the arrangement of compounds, streets, and central structures. Walking the ruins today, one senses the interplay of environment, design, and human intention. Coral blocks rise in repeated sequences, walls maintain proportional heights, and streets frame sightlines that draw attention to key buildings. Geometry structures, perception. Even without roofs, one can perceive the planned relationships among compounds, plazas, and thoroughfares. The experience is immersive, revealing that precision can exist in harmony with organic growth, rather than through rigid imposition. Speculative interpretations invite further intrigue. Could Gedi's city planners have applied principles of proportion or modular design, repeating unit sizes to regulate construction and ensure structural integrity? Were compounds deliberately mirrored or aligned with cardinal directions, perhaps reflecting cosmological or cultural ideals? If so, the city becomes more than a settlement. It becomes an orchestrated environment, a tangible expression of collective knowledge encoded in coral and sand. The choice of coral as building material is itself remarkable. Coral is lightweight, durable, and thermally resilient, yet it requires skill to quarry, shape, and fit precisely. Its use suggests an empirical understanding of material properties, how blocks interact, how weight is distributed, and how structures withstand environmental stressors such as humidity, wind, and occasional storms. Gedi's builders were not only masons, they were applied mathematicians, engineers, and planners in a single integrated practice. Another dimension emerges when considering water management. The city occupies a coastal plain subject to tidal influence. Drainage channels and strategic placement of wells indicate an understanding of hydrology, slope, and soil behavior. Streets and compounds were likely arranged to optimize flow, prevent flooding, and provide access to fresh water. Here, spatial planning intersects with environmental science, a form of proto-engineering expressed through layout, slope, and orientation. Yet Gedi retains mysteries. Many compounds remain unexcavated, and some streets vanish beneath vegetation or modern development. The relationship between elite and common residential areas is not fully understood, and ritual or communal functions may be hidden in foundations or subsurface features. Some buildings contain traces of imported materials, pottery, beads, or architectural elements that hint at trade networks, but how these influenced urban design remains speculative. Like the Proto-Engineering of Marib, the Tasmola rings, and Zorats before it, Gedi demonstrates that mathematical awareness manifests across cultures and mediums. Here, precision is neither monumental nor abstract. It is functional, aesthetic, and adaptable, embedded in the fabric of daily life. The city embodies order without rigidity, control without domination, a lesson in how geometry and proportion can coexist with organic growth. Modern visitors walking the coral streets can sense both the planning and the human stories embedded within. The alignment of compounds, the repetition of walls and courtyards, and the careful spacing of public buildings convey intention. Mathematics, proportion, and environmental understanding converge in a lived space, one that supported centuries of occupation, trade, and social organization. And yet, the questions endure. Did city planners employ formalized measurement techniques, or rely on rules of thumb and experience? Were street widths, compound sizes, and central plazas guided by ritual, social hierarchy, or purely practical needs? How much knowledge has been lost to time, vegetation, and erosion? And what other aspects of urban sophistication, hidden infrastructure, unexcavated foundations, or subtle spatial codes await discovery beneath the coral and soil? Standing amid the ruins, the city's silent geometry becomes palpable. Streets align, walls rise in proportion, and compounds articulate space with subtle intention. Gedi's coral stone city planning offers a reminder that mathematical precision need not always be monumental. It can reside in everyday life, in the arrangement of buildings, streets, and communal spaces. It is a testament to human ingenuity, to observe, measure, and impose order while remaining responsive to the environment and cultural needs. And so Gedi remains, half reclaimed by forest and tide, its geometry whispering across centuries. Its streets, walls, and courtyards invite reflection on how human societies have understood space, proportion, and design, and how much of that knowledge continues to lie hidden, waiting for patient observation to uncover the mathematical intelligence embedded in our shared past. As the coral streets and carefully arranged compounds of Gedi recede behind us, a new chapter in humanity's fascination with geometry unfolds, not on coastal plains or urban grids, but deep beneath the earth, where water and stone converge in sacred harmony. Here, precision is hidden from immediate view, embedded in subterranean spaces that have endured for millennia, inviting contemplation of proportion, alignment, and cosmic intention. On the rugged island of Sardinia, Italy, the Nuragic civilization left an enduring legacy of stone towers, fortifications, and ceremonial structures. Yet few are as enigmatic or mathematically intriguing as the sacred wells. Known locally as pozzi sacri, these subterranean structures consist of circular wells accessed through descending stairways, often constructed with dry stone masonry so precise that even the smallest stone fits snugly into its neighbor. They are functional, yes, but also symbolic, their design reflecting principles of geometry, proportion, and perhaps celestial alignment. From above, the wells appear modest, mere circles interrupting the landscape of hills and plateaus. Yet descending into the central shaft reveals careful construction. Steps spiral downward with regularity, walls curve in measured arcs, and water, when present, occupies a space that seems intentionally defined. Light and shadow move through these shafts in predictable ways, particularly during solstices and equinoxes, hinting at a knowledge of solar cycles encoded into the architecture. Archaeological evidence dates the construction of these sacred wells to the Late Bronze Age, roughly between 1200 and 800 BC, though some features may predate this period. They are often located near Nuragic villages or ceremonial complexes, suggesting that they served both practical and ritual purposes. Water was central to survival and society, but the design of these wells elevates it beyond utility. Geometry becomes sacred, proportion becomes experience. The arrangement of stones is meticulous. The central circular shaft is carefully measured, the diameter uniform and consistent across multiple examples. Steps descend at regular intervals, their rise and run calibrated for ease of access while reinforcing symmetry. Even the entrance corridors are aligned to the shaft with subtle precision, guiding movement and perception. In this way, mathematics manifests not in abstract symbols but in lived experience. Descending the well becomes a physical dialogue with proportion, order, and intention. Mainstream interpretations describe the wells primarily as ritual sites, used for libations, purification, or other sacred activities. Some wells are associated with altars, niches, or carved features, while others are linked to astronomical phenomena. In particular, studies suggest that during certain times of the year, sunlight penetrates the shaft to illuminate specific points within the structure, a deliberate interaction of geometry and celestial observation. Could this reflect a sophisticated understanding of solar paths, applied over generations, or an intuitive awareness of environmental cycles? Speculative perspectives extend the intrigue. Might the Nuragic builders have encoded knowledge of proportion and geometry as part of ritual practice, merging mathematics with spiritual experience? Could the placement of wells within a broader landscape follow precise spatial patterns, connecting villages, temples, or other ceremonial sites through sightlines, distance, or orientation? The question invites reflection on the interplay between environment, cosmology, and human ingenuity. The construction techniques reinforce the sense of precision. Large blocks of local stone were cut, leveled, and fitted without mortar, forming stable walls capable of lasting millennia. The concentric arrangement of stones within circular shafts reflects careful calculation, while the spiral stairways descend in predictable gradients. Even the curvature of walls appears intentional, producing a space that is both stable and harmonious, a subtle expression of applied geometry. Orientation and alignment further deepen the mystery. Many sacred wells appear positioned relative to celestial events, water sources, or topographical features. At Santa Cristina, one of the most studied wells, the setting sun during the solstice illuminates the interior in a precise, fleeting moment. Similar alignments at Fontana Coberta and other sites suggest a consistent knowledge of solar and seasonal cycles. Here, mathematics becomes temporal as well as spatial, coordinating observation with human activity in ritual, survival, or both. Yet the question of intent remains unresolved. Were these alignments functional, symbolic, or both? Were they designed for elite religious practitioners, for entire communities, or for a combination of purposes? What proportion of the design reflects deliberate planning, and what emerged organically through long-term adaptation? The answers lie partially hidden in stone and soil, requiring careful measurement, reconstruction, and interpretation. Comparisons with other ancient mathematical constructions illuminate the broader significance. Like the Proto-Engineering of Marib, the Tasmola rings, and the coral stone planning of Gedi, the Nuragic sacred wells demonstrate that early societies could encode precise knowledge into physical space. Geometry was not an abstract intellectual exercise. It was applied, experiential, and intimately connected to daily life, ritual, and environment. In Sardinia, as elsewhere, mathematics shaped movement, perception, and interaction with the natural world. Descending a sacred well today, one experiences this subtlety firsthand. Each step reinforces the rhythm of proportion. The cylindrical walls guide the eye toward the center. Light moves in predictable arcs. The sound of footsteps echoes in measured cadence. The act of entering becomes a journey through geometry itself, a dialogue between human intention and the built environment. And yet, much remains unknown. Subsurface structures, unexcavated wells, and partial collapses obscure the full extent of the design. Were there additional features, perhaps aligned corridors, ceremonial platforms, or hidden chambers, that extended the mathematical and ritual complexity? How many principles of proportion, alignment, or harmonic resonance remain encoded in stone, waiting for patient observation to reveal them? The Nuragic sacred wells remind us that mathematics need not always be monumental or overt. Here, it is subtle, embedded in circularity, proportion, and spatial experience. Geometry becomes lived experience, ritual becomes measurement, and human ingenuity merges with the natural and celestial environment. And so, beneath the Sardinian hills, these wells endure. Their circles of stone invite reflection across millennia, prompting us to wonder, how much knowledge, encoded in subtle alignments and precise proportions, remains hidden in the earth, waiting to be rediscovered? How many ancient societies applied mathematical intelligence not only to construction, but to ritual, observation, and the very act of living in harmony with their environment? The Nuragic sacred wells leave their silence as both guide and challenge, proof that precision, geometry, and human intention can endure unseen for thousands of years, whispering their logic to those willing to listen and observe. As the circular wells of Sardinia fade behind us, descending into subterranean geometry and the rhythm of water and stone, our journey returns once more to the surface, tracing the contours of human ambition across Europe. Here, mathematics is no longer hidden beneath the ground or encoded in ceremonial alignment. It rises in formidable walls, ramparts, and gateways, marking boundaries of protection, authority, and communal design. We arrive at Los Millares, an ancient fortified settlement perched on the sun-baked plains of southeastern Spain, where precision, labor, and strategy converge in stone. From a distance, Los Millares appears as a series of concentric circles etched into the landscape, walls rising from low hills, encircling homes, streets, and burial grounds. The outer fortifications stretch in arcs and straight lines that follow topography while asserting control, while inner walls form a labyrinth of enclosures whose proportions suggest forethought and repeated planning. At first glance, the layout might seem defensive alone, yet closer inspection reveals alignment, spacing, and geometrical relationships that hint at a broader intelligence. Constructed during the Chalcolithic period, roughly between 3200 and 2300 BC, Los Millares is one of the earliest examples of large-scale fortification in Europe. Its walls, composed of carefully cut limestone blocks, rise up to 6 meters in height in some sections, reinforced with rubble fill and bastions at key points. The scale is impressive, yet the precision is equally remarkable. Gateways are framed with corbelled arches, angles are consistent, and multiple concentric rings maintain uniform separation, creating both defensive depth and organized space. Archaeological excavations have revealed that the fortifications were not merely functional. The spacing of walls, gateways, and internal enclosures appears to follow repeated proportional patterns, suggesting that the builders applied rules of geometry to manage movement, access, and control. The placement of towers and bastions aligns with sight lines that maximize visibility across surrounding plains, indicating not only strategic but spatial intelligence. Mainstream interpretations emphasize the defensive role of Los Millares. The settlement protected inhabitants from rival groups, facilitated control of nearby resources, and projected authority across the landscape. Yet defense alone does not explain the mathematical subtlety evident in wall curvature, interval spacing, and concentric layering. The geometry conveys order. Repeated units, precise distances, and harmonious proportions create a structural logic that transcends mere protection. Within the fortifications, residential compounds reveal additional evidence of planning. Houses are semi-subterranean, arranged in clusters that preserve orientation and spacing. Streets follow subtle curves, directing movement while maintaining visibility across compounds. Cemeteries lie adjacent to the settlement, containing collective tombs whose sizes and orientations echo proportional relationships found in the walls themselves. In these arrangements, mathematics, ritual, and daily life intersect, forming a coherent spatial system. Some researchers have speculated that Los Millares was more than a defensive settlement. It may have served as a regional center of coordination, ceremony, and administration. The geometry of fortifications could have reinforced social hierarchy, delineating spaces for elites, artisans, and communal gatherings. Repetition and proportion may have communicated authority, order, and cultural knowledge, embedding social intelligence into the very stones of the walls. The construction techniques reveal additional sophistication. Limestone blocks were quarried, cut, and assembled without mortar, relying on precise fit and weight distribution for stability. Curved walls were carefully measured to maintain consistent radii, while bastions were positioned to strengthen corners and create overlapping fields of observation. This is applied mathematics in practice. Angles, weight, and geometry combine to produce structures both durable and harmonious. Yet the purpose of the fortifications remains partially enigmatic. Some walls contain internal features, niches, recesses, and internal corridors, whose function is not fully understood. Were these purely structural, or did they serve ceremonial, observational, or symbolic roles? The alignment of walls relative to nearby hills and watercourses raises further questions. Were topography and resource networks incorporated intentionally, perhaps encoding environmental knowledge into the settlement plan? Comparison with other sites explored in this series illuminates recurring themes. Like the Nuragic wells, Gedi's coral stone streets, and the Tasmola rings, Los Millares demonstrates that early societies could integrate mathematical precision into practical and social design. Geometry appears not as an abstract concept but as a tool to organize space, mediate human interaction, and encode knowledge across generations. At Los Millares, mathematics structures both survival and society. Walking through the ruins today, one perceives the scale and care embedded in every wall and bastion. The concentric rings guide perception, defining pathways and boundaries. Gateways frame views, directing attention while controlling access. Internal enclosures create a rhythm of space that feels deliberate, even as centuries of erosion and collapse have softened the original clarity. The settlement communicates a sense of order that is both functional and intellectual, a dialogue between builders and landscape. Speculative questions remain. How many principles of proportion or alignment guided construction, beyond what is evident today? Were the concentric walls and bastions symbolic, reinforcing cosmological or ritual significance, or entirely practical? How did labor, surveying, and measurement function in a society without written numerical notation, yet capable of achieving such remarkable precision? These questions highlight the enduring tension between what we can observe and what remains hidden in the logic of the stones. Like other ancient sites we have explored, Los Millares reminds us that mathematics can manifest subtly in spacing, proportion, and repetition, rather than in explicit inscription. Geometry shapes movement, defines communal structure, and embeds knowledge in the landscape. The Chalcolithic builders of Los Millares were not only masons and warriors, they were planners, observers, and applied mathematicians, translating abstract principles into lived, defensible space. And yet, despite millennia of study, mysteries remain. Subsurface features, partially collapsed walls, and unexcavated areas hint at a more complex settlement plan than what is visible today. Were additional walls, outlying structures, or ceremonial platforms part of the original vision? How did geometry inform social and ritual functions within the community? The answers are hidden in layers of earth and stone, awaiting patient excavation and observation. Standing among the ruins of Los Millares today, the concentric fortifications convey both human ingenuity and enduring mystery. The walls endure as silent teachers, demonstrating that mathematics and design were as integral to life as defense and ritual. The geometry of stone encodes knowledge, organization, and intention, subtle yet persistent, challenging us to perceive the intelligence of builders long past. And so, as the sun casts long shadows over the concentric bastions, one is left with a quiet question: how many other principles of proportion, alignment, and mathematical insight remain hidden in settlements yet to be discovered? How much knowledge did the Chalcolithic builders of Los Millares encode in stone, only partially legible to those who walk the site thousands of years later? The settlement endures, inviting reflection on the intersection of human intelligence, geometry, and the physical world. As the sun dips over the fortified rings of Los Millares, casting long shadows across walls that have endured millennia, our journey now carries us eastward, across deserts and river plains, into one of the earliest urban landscapes in human history, the Indus Valley. Here, mathematics and order are not expressed in monumental fortifications or sacred wells alone, but in the subtle, deliberate patterns of life, death, and ritual. It is within the cemeteries of Harappa, specifically Cemetery H, that the precision and structure of an ancient civilization reveal themselves in both profound and puzzling ways. Cemetery H lies on the outskirts of what was once a bustling metropolis of the mature Harappan period, roughly 2600 to 1900 BC. The area stretches over a low, sandy plain, now punctuated by mounds of soil and scattered fragments of brick and pottery. Excavation reveals rows of graves, carefully oriented along consistent axes, their spacing uniform, their construction systematic. Unlike earlier burials in the region, which might seem ad hoc or irregular, Cemetery H exhibits a striking awareness of proportion, alignment, and repetition. From above, the arrangement appears almost architectural. Graves follow linear patterns, often clustered in blocks, with minor variations in size and orientation that may correspond to age, sex, or social role. Each grave is meticulously constructed, sometimes lined with baked bricks, sometimes marked with stone or wooden elements. Within them lie remains accompanied by personal objects, beads, pottery, copper tools, and ornaments. While these items may suggest ritual or status, the geometry of the cemetery itself, the consistent spacing, the parallel alignment of rows, the repeated use of measurement, suggests an underlying logic that transcends the individual. Archaeologists interpret Cemetery H primarily as a necropolis, yet its systematic layout hints at a broader consciousness, an awareness of human scale, spatial order, and temporal continuity. Could the planners have applied rules of proportion to the cemetery, ensuring that each burial fit within a larger, organized framework? Was this an early expression of civic planning applied to the afterlife, mirroring the urban grids of Harappa itself? The parallels are striking. In the city, streets run at right angles, houses occupy measured plots, and drains align with precision. In the cemetery, the same attention to alignment and spacing appears, suggesting continuity of mathematical thinking across life and death. The graves themselves provide additional intrigue. Some are rectangular, others oval. Some are shallow, others deeply dug. Certain clusters exhibit repeated dimensions, while others break pattern, hinting at exceptions that may reflect ritual, status, or chronology. The repetition of length, width, and orientation across multiple graves suggests an empirical awareness of proportion, perhaps transmitted orally or through apprenticeship. Even subtle adjustments, for instance to accommodate irregular terrain, demonstrate practical problem-solving grounded in geometry. Cemetery H also contains anomalies that provoke deeper speculation. Some graves are deliberately placed near older mounds or ritual markers. Others are oriented to the rising or setting sun during particular times of year. Could these alignments have functioned as temporal markers, guiding communal memory or ritual practice? Were celestial cycles encoded into the layout, blending mathematics, cosmology, and social cohesion? The evidence is tantalizing but inconclusive, leaving room for interpretation without the need for exaggeration. Excavation reports reveal another layer of subtlety. Mortuary practices varied in accordance with design. Certain graves are framed with carefully leveled bricks, while others are bordered with stone slabs. Some contained multiple individuals, suggesting familial or social grouping, while others were solitary. Yet, the consistent orientation and spacing across the site imply a governing principle, that even within variation, order was maintained. Mathematics, proportion, and spatial awareness were expressed not only in construction, but in arrangement, pattern, and relational design. The use of measurement is particularly striking. While no written manuals or standardized tools have been recovered, the consistency of grave dimensions and spacing suggests practical units of measure. Were these based on the human body, pacing, or rudimentary rods? Were proportions culturally defined, passed down orally, or codified in some lost system? These questions emphasize the sophistication of the Harappan mindset. Mathematics as lived experience, embodied in the alignment of stone, brick, and earth. Mainstream archaeology has long noted the juxtaposition of order and anomaly in Cemetery H. Some burials lie outside the regular grid. Some contain unusual assemblages of goods. Were these intentional deviations, reflecting social nuance, ritual exception, or personal choice? Or do they hint at aspects of Harappan society that remain invisible to modern investigation? Whatever the explanation, the overall precision of the cemetery underscores the capacity of early urban cultures to integrate geometry, planning, and ritual into both life and death. The parallels to other sites explored in this series are compelling. Just as the Tasmola rings, Gedi, and Los Millares demonstrate deliberate placement and spatial awareness, Cemetery H manifests precision in mortuary architecture. Geometry here is not monumental, yet it is persistent, a quiet intelligence embedded in soil, brick, and alignment, awaiting recognition by those attuned to proportion and rhythm. The cemetery becomes a reflection of civic values, social order, and an early form of mathematical consciousness expressed in the human landscape. Walking among the graves today, one senses the continuity of attention and care. Each row guides the eye along a predictable path. Each burial reinforces the rhythm of the cemetery. Even absent the human presence of millennia past, the layout conveys deliberate thought, proportion, and order. Geometry and ritual converge to create a space both functional and symbolic, tangible and conceptual, earthly and transcendent. Yet mysteries endure. How were decisions made regarding placement, orientation, and clustering? What rules guided exceptions, and what cultural or spiritual significance lay behind deviations? How did mortuary practice interact with urban planning, environmental conditions, and societal hierarchy? And most compellingly, what elements of mathematical knowledge, embedded in the layout and construction, remain invisible without patient measurement and observation? Cemetery H reminds us that precision and order can exist in contexts that are subtle, ephemeral, and deeply human. Mathematics does not always manifest in monumental walls, aligned stones, or grids of streets. It can emerge quietly in the spacing of graves, the alignment of burial rows, and the proportionality of human-scale construction. It is applied, experiential, and enduring, bridging life, death, and the conceptual understanding of space. And so, as one stands among the Harappan graves, The alignment of bricks and stones whisper across millennia. They challenge us to recognize intelligence in subtle forms, to perceive the principles of geometry woven into patterns of life and death, and to wonder, what other layers of mathematical and spatial knowledge remain hidden in landscapes we have yet to study, waiting patiently to reveal the sophistication of civilizations long past. As the rows of Harappa Cemetery H recede into memory, a landscape of deliberate order, proportion, and mathematical awareness, our journey now carries us across continents and altitudes to a place where geometry meets vertigo and human ingenuity confronts the clouds. Nestled in the misty highlands of northern Peru, amid dense cloud forests and precipitous cliffs, rise the mausoleums of the Chachapoya, a people whose architectural precision and spatial intelligence transform the sheer sides of mountains into sanctuaries of stone and air. From a distance, the Chachapoya funerary sites appear almost impossible, clinging to cliffs with what seems like casual defiance of gravity. The walls of circular and rectangular mausoleums rise from ledges and terraces, composed of finely fitted stones without mortar, their forms echoing the contours of the rock beneath. Some structures are built in tiers, others incorporate natural caves, while narrow stairways and carved platforms connect different levels. The combination of placement, orientation, and construction suggests a mastery of both environment and form, revealing a civilization attuned to mathematics, proportion, and structural ingenuity. Archaeological evidence places the construction of these mausoleums between approximately 900 and 1500 AD during the late pre-Columbian period. Unlike other burial traditions in the Andes, the Chachapoya integrated their mortuary architecture directly with the landscape, creating structures that are not only functional but deliberately harmonious with cliffs, overhangs, and natural terraces. The geometry of each mausoleum reflects careful planning. Walls are circular or rectangular with precise angles, doorways are proportionally scaled, and niches or internal partitions exhibit repeated measurement principles. The purpose of these mausoleums was primarily funerary, housing mummified remains of individuals, often of high social status or communal importance. Yet the precision of their construction and the complexity of their arrangement suggest broader considerations: visual impact, structural stability, and perhaps even cosmological alignment. Were the entrances and windows oriented to catch the morning sun or frame particular celestial events? Were terraces and stairways calculated to facilitate ritual processions or observation points? These questions remain open, yet the consistency of form across hundreds of sites hints at a shared system of spatial knowledge. Mainstream scholarship emphasizes the Chachapoya as a warrior and agrarian society, navigating steep terrain with mobility and fortification. Their settlements on ridges and in valleys demonstrate strategic placement, but the mausoleums go further. They translate environmental challenge into architectural opportunity. Precision is evident in stone cutting, placement, and leveling, despite the apparent chaos of cliff faces. Stones fit tightly, courses are level, and walls rise straight despite being anchored to uneven rock. Such construction implies not only skill, but a sophisticated understanding of geometry, balance, and proportion. Some mausoleums are circular, others rectangular, yet both types exhibit internal consistency. Measurements of doorways, niches, and internal chambers often follow repeated ratios, suggesting standardized planning or rules of proportion transmitted across generations. Were these principles symbolic, ritual, or purely practical? Did they reflect a cultural encoding of mathematics, ensuring harmony, stability, and aesthetic consistency across sites? We may never know fully, but the pattern is unmistakable. Human intelligence sculpted the environment with care, deliberate measurement, and awareness of spatial relationships. The Chachapoya also demonstrated ingenuity in integrating mausoleums with natural caves, ledges, and terraces. In some cases, funerary structures extend into rock overhangs, using gravity and slope to enhance stability. Narrow stairways carved into cliffs provide access while maintaining separation and security. The spatial logic is intricate. Elevation protects from moisture, predators, and human intrusion, while the geometry ensures longevity and proportion. Mathematics is practical here, structural, applied, and inseparable from environmental awareness. Speculative interpretations deepen the mystery. Some researchers propose that the placement of mausoleums may reflect a networked cosmology, connecting prominent peaks, valleys, or rivers with visual sightlines and spatial order. Could these alignments encode ritual pathways, astronomical observation points, or a symbolic mapping of the Chachapoya world? Others suggest acoustic or resonant properties. Circular stone walls on cliffs may have amplified sound for ceremonies, merging physical design with sensory experience. Whether factual or theoretical, such ideas underscore the sophisticated interplay of mathematics, landscape, and ritual intelligence. The interior spaces also reflect precise proportion. Chambers are sized to accommodate multiple mummies, ritual offerings, or periodic visitation, with niches and recesses carefully calculated to maximize volume and structural integrity. Some mausoleums contain staircases or passageways, where angles and steps maintain uniformity, suggesting conscious attention to modularity and human scale. Even minor variations, observed across different structures, hint at adaptation to specific cliff conditions without compromising overall spatial harmony. Like other sites explored in this series, from Harappa to Los Millares, from Tasmola to Gedi, the Chachapoya mausoleums reveal a global pattern. Human societies across time and space embedded mathematical knowledge into lived experience, whether through funerary practice, urban planning, or ritual architecture. Geometry is never abstract. It manifests in proportion, alignment, and relational placement. In the high cloud forests, mathematics meets ecology, topography, and ritual in a seamless dialogue. Walking along narrow ledges today, one senses the deliberate intent of the builders. The cliffs themselves seem transformed, shaped to accommodate human vision, movement, and ritual. Every stone, every angle, every wall expresses both technical skill and aesthetic intelligence. The geometry, while subtle, is palpable, guiding perception, controlling movement, and harmonizing with the natural environment. The mausoleums are simultaneously functional, symbolic, and geometrically coherent, a testament to applied knowledge in challenging terrain. Yet much remains unexplored. Dense vegetation conceals terraces, unexcavated caves, and potential mausoleums. Structural collapse and erosion obscure the full extent of the design, leaving unanswered questions about orientation, proportional systems, and networked relationships across sites. How are these principles transmitted across generations, particularly in a society without written mathematical notation? What other forms of measurement, rhythm, or spatial intelligence remain hidden in the cloud forest, encoded in stone and topography? The Chachapoya mausoleums remind us that mathematics can be both subtle and monumental, evident in proportion, repetition, and alignment rather than sheer scale. Precision resides in placement, in stairways, in walls that cling to cliffs. Geometry becomes both functional and symbolic, structuring the human experience of the environment while encoding knowledge for future generations. These cliffside tombs are more than mortuary architecture. They are a dialogue between human intelligence, landscape, and time. And so, amidst the mist and cloud of northern Peru, the Chachapoya mausoleums endure as silent witnesses. Their walls, terraces, and chambers challenge us to recognize the intelligence embedded in proportion, alignment, and adaptation. They invite reflection on what other principles of geometry, measurement, and environmental integration might remain hidden in landscapes across the globe. In these high forests, mathematics, ritual, and architecture converge, leaving a mystery that continues to whisper across the centuries, awaiting patient observation to uncover the full depth of human ingenuity. As the mist of the Peruvian cloud forests slowly lifts from the Chachapoya mausoleums, revealing terraces and cliffside tombs that merge architecture with environment, our journey now winds across continents and mountains to the remote valleys of northern Pakistan. Here, among rugged peaks, rushing rivers, and hidden plateaus, lie the burial grounds of the Kalasha people, a culture whose mortuary practices present anomalies that challenge conventional understanding. The patterns of placement, orientation, and construction hint at principles of spatial awareness, proportion, and possibly mathematical intent embedded within their funerary tradition. The Kalasha inhabit the Chitral district, a region defined by steep mountains, narrow valleys, and dense woodlands. Within this landscape, scattered across ridges and meadows, are ancient burials, some marked with stones, others with wooden markers, yet all placed with a peculiar consistency that draws the attention of anthropologists and archaeologists alike. Unlike simple interments, these graves often display subtle regularities: alignment with cardinal points, repetition of orientation, and recurring spatial relationships between clusters of burials. At first glance, the placements seem intuitive, shaped by terrain, yet closer examination suggests deliberate patterning. Some graves are solitary, nestled into slopes or terraces, while others appear in clusters, forming compact cemeteries that occupy a distinct portion of the landscape. These clusters often follow linear arrangements, with spacing that is neither random nor entirely dictated by topography. Observers note that many burials maintain consistent distances from one another, and some markers exhibit repeated geometric forms: rectangular slabs, circular cairns, and occasionally more intricate stone configurations. Across the valleys, the consistency of these arrangements suggests knowledge of measurement, proportion, and relational placement. Historical analysis places some of these burials within the late prehistoric to early historic period, though precise dating is often difficult due to environmental conditions and limited excavation. Radiocarbon results from nearby organic materials suggest a time frame extending from roughly 1000 BC to the first millennium AD, overlapping with broader developments in South and Central Asia. During this period, the Kalasha maintained social and ritual structures deeply connected to landscape, climate, and spiritual practice. The mathematical order observed in their burials may therefore reflect a sophisticated integration of environmental intelligence with ritual tradition. The burial anomalies lie not only in placement, but also in construction. Some graves are aligned with the slope of hills, while others appear oriented to celestial phenomena: sunrise, sunset, or the transit of specific stars. Certain clusters repeat proportions. Grave lengths, widths, and distances between markers echo ratios found elsewhere, hinting at a standardized approach to mortuary layout. Were these rules transmitted orally, codified in ritual memory, or applied through careful observation of the landscape? The evidence suggests deliberate attention to geometry, even in contexts primarily concerned with death and commemoration. Material elements within these burials also reveal an underlying logic. Simple stone markers are sometimes placed with exact spacing around burial pits, while wooden structures, when preserved, mirror proportions seen in stone arrangements. Objects interred with the dead, ceramics, tools, ornaments, appear to follow consistent spatial relationships relative to the body or grave perimeter. This interplay between geometry, material, and placement suggests that mathematics was not abstract, but practical, guiding how sacred space was constructed and experienced. Some anomalies are more enigmatic. Certain burials deviate from the apparent proportional norms, Markers may be rotated, placed at unusual angles, or isolated from other graves. Others show evidence of post-interment modification, stones rearranged, pits deepened, or markers added centuries later. Are these deviations reflective of social distinctions, ritual exception, or evolving cultural norms? Or might they indicate an encoded knowledge system, where geometric patterns were adapted over generations to reflect cosmology, seasonality, or communal memory? The answers remain elusive, leaving room for careful speculation. The Kalasha burial sites also reveal intriguing relationships with topography. Many graves occupy terraces that overlook valleys, rivers, or strategic mountain passes, creating sightlines that may have functioned as visual markers within the landscape. In some cases, alignment with peaks or watercourses suggests integration of natural geometry with human-made arrangement. Did the builders calculate these placements with an eye to symmetry, proportion, or orientation, or was it an empirical understanding of spatial harmony honed over generations? The question is open, yet the consistency of patterns across valleys indicates intentionality. Comparisons with other mathematical sites explored in this series illuminate the broader significance. Like the Chachapoya mausoleums clinging to cliffs, the Nuragic sacred wells, or Los Millares Fortifications, the Kalasha burial arrangements demonstrate that early societies integrated geometry and measurement into practical, ritual, and spatial contexts. Here, mathematics is not abstract or ceremonial alone. It is applied in proportion, alignment, and relational placement, bridging environmental adaptation with social and spiritual function. Walking through a Kalasha cemetery today, one senses the subtle intelligence embedded in the landscape. Each marker guides the eye along a ridge or slope, echoing patterns of repetition and spacing. Clusters of graves suggest communal identity, while orientation and alignment hint at cosmic or seasonal awareness. Even the smallest stone marker appears intentional, its placement resonating with neighboring burials to create an overall harmony that speaks of observation, planning, and care. Yet mysteries persist. How were measurement and proportion taught and transmitted without formal mathematical notation? Were deviations from pattern symbolic, functional, or accidental? Did the Kalasha encode knowledge of landscape, season, or astronomy into the layout of graves? And how much information, spatial, social, or ritual, remains hidden beneath soil, vegetation, or centuries of erosion? These questions underscore that while patterns are visible, their full significance is still beyond our grasp. The burial anomalies of the Kalasha remind us that human intelligence and mathematical awareness manifest in subtle, enduring ways. Precision can reside not in monumental architecture or stone circles, but in the spacing of graves, the orientation of markers, and the proportionality of communal layout. Mathematics here becomes experiential, spatial, and intimately tied to culture, ecology, and ritual practice. And so, perched in high valleys and quiet slopes, the Kalasha graves endure as silent witnesses to a sophisticated understanding of space, proportion, and human intention. Their alignment, spacing, and geometry challenge us to recognize subtle intelligence encoded in the landscape and to wonder what other principles of mathematical awareness, spatial reasoning, or cosmological knowledge remain hidden, waiting for patient observation to reveal the depth of human ingenuity across time. As the misty valleys of the Kalasha highlands recede behind us, with their carefully measured burial clusters and subtle alignment anomalies, our journey now moves southward across continents and millennia, to a land where the desert meets the Nile, and where the dead are hidden not on cliffs or valleys, but beneath the sands themselves. Here, at Dra Abu el-Naga, on the west bank of Luxor, Egypt, lie hidden shafts and subterranean chambers that whisper of deliberate precision, secrecy, and knowledge lost to time. a testament to human ingenuity applied beneath the earth. From above, Dra Abu el-Naga appears as a scattering of low mounds, rocky outcrops, and sun-baked terrain, interspersed with tomb entrances partially concealed by wind-blown sand. Yet, beneath this seemingly ordinary surface lies a labyrinth of shafts, descending steeply into the bedrock. Some are narrow, mere passages for the body of a single interment, while others widen into chambers with multiple recesses, niches, or corridors. The architecture, though subterranean, exhibits deliberate proportions. Shafts are positioned with consistent intervals. Angles of descent are calculated to maintain structural integrity, and internal chambers often follow repeated geometric patterns. Archaeological evidence dates much of Dra Abu el-Naga to the early New Kingdom, approximately 1550 to 1290 BC, though some tombs and shafts may predate this period. The site served as a necropolis for the Theban elite, including priests, officials, and royalty, but its concealed and layered design suggests functions beyond mere burial. Access to the deeper shafts often required careful maneuvering, suggesting that the placement and orientation of tombs were intended to restrict entry, perhaps preserving sanctity or secrecy. The shafts themselves reveal remarkable consistency in construction. Steps and ramps descend at calculated angles, walls are dressed and smoothed to maintain uniformity, and chambers are carved with attention to proportion. In some instances, nested recesses mirror the dimensions of other chambers, creating a modular repetition that hints at an underlying system of measurement. Was this system symbolic, practical, or both? Could the repeated ratios reflect ritual significance, structural necessity, or an early expression of architectural mathematics? The evidence resists simple interpretation, inviting deeper contemplation. Mainstream archaeology interprets the hidden shafts as tombs or mortuary chambers, designed to house the deceased and accompany them in the afterlife. Funerary artifacts, canopic jars, amulets, pottery, and inscriptions underscore the ritual purpose of these spaces. Yet the precision of the shafts, their spatial relationships, and the repetition of forms hint at a sophistication beyond mere interment. The architects of Dra Abu el-Naga appear to have applied geometry and proportionality to subterranean design, translating abstract principles into practical, hidden spaces. Orientation is one of the most intriguing aspects. Some shafts align with cardinal points, while others appear positioned relative to neighboring tombs or natural landmarks. Certain chambers are illuminated by shafts of light at specific times, suggesting awareness of solar movement. Could these alignments encode cosmological or ceremonial knowledge? Were shafts positioned to track celestial cycles, to facilitate ritual observation, or to harmonize with a larger landscape of mortuary sites? The evidence is tantalizing but inconclusive, allowing speculation without requiring exaggeration. Construction techniques further reveal the intelligence embedded in design. Stone surfaces are smoothed, corners are squared or slightly angled, and chambers are often carved to exact proportions. Some shafts include internal ledges, niches, or stairways carefully integrated into the bedrock, balancing structural stability with functional access. Even minor deviations, when compared across the necropolis, suggest adaptation to bedrock variations, showing practical problem-solving grounded in applied measurement. Yet anomalies abound. Some shafts are unusually narrow or deep. Others are partially collapsed or filled with debris. Certain chambers contain architectural features that appear unrelated to funerary practice: angled recesses, secondary shafts, or irregular corridors. Were these intentional, reflecting ritual differentiation, symbolic encoding, or experimental construction? Or do they represent a level of complexity lost to time, where mathematics, environment, and ritual intersected in ways we can only partially reconstruct? The hidden shafts of Dra Abu el-Naga also suggest a broader urban and topographical awareness. The necropolis is part of a network of mortuary sites across Thebes, with tombs positioned in relation to one another and to the Nile Valley. Lines of sight, access routes, and orientation may have been deliberately considered, linking tombs visually, ritually, or astronomically. In this context, subterranean architecture becomes not only mortuary, but also spatial intelligence, integrating knowledge of topography, geometry, and social hierarchy. The parallels with other sites in this series are striking. From Kalasha burial anomalies to Chachapoya cliff mausoleums, and from Harappa cemeteries to Los Millares fortifications, we observe recurring themes: geometry applied to function, measurement embedded in ritual, and spatial awareness extending across generations. At Dra Abu el-Naga, these principles manifest underground, in shadowed shafts and hidden chambers, demonstrating that mathematical intelligence was expressed not only in visible monuments, but also in concealed, deliberate spaces. Walking within the necropolis today, one senses the logic and intent behind each descending shaft. The angles of steps, the spacing of walls, and the repetition of chamber dimensions communicate an awareness of proportion and relational design. Even in partially excavated or eroded shafts, the rhythm of construction, rise and run, width and height, repetition and symmetry, remains palpable. The architecture conveys both functional knowledge and cultural intention, an intelligence encoded in stone, shadow, and void. Yet many questions remain unanswered. How were proportions determined without standardized written units? How were shafts coordinated across the necropolis to maintain alignment, structural safety, and ritual order? What might the anomalies, irregular corridors, secondary chambers, or concealed recesses, reveal about lost practices, esoteric knowledge, or alternative functions of these subterranean spaces? And how many hidden shafts, yet undiscovered beneath the sands and rock, may further illuminate the sophistication of ancient Theban engineering? The hidden shafts of Dra Abu el-Naga remind us that mathematics and spatial intelligence can be expressed in quiet, subterranean forms. Precision does not require grandeur or visibility. It can reside in angles, alignment, and proportion carefully applied to functional and ritual needs. Here, the architects combined geometry, structural knowledge, and cultural intention to produce spaces that endure for millennia, waiting for patient observation to reveal their logic. And so, beneath the desert sun and layers of sand, the hidden shafts endure, silent, precise, and enigmatic. They challenge us to recognize subtle intelligence in the buried and the concealed, to trace mathematics applied without inscription, and to wonder how much knowledge encoded in angles, alignments, and hidden chambers remains obscured beneath the earth, waiting to reveal the ingenuity of civilizations long past. As the hidden shafts of Dra Abu el-Naga recede into shadow, their angles, proportions, and subterranean precision still echoing in our minds, our journey now carries us northwest, across the Mediterranean, to the rugged hills of Sardinia. Here, among rolling plains, rocky outcrops, and windswept ridges, lie the enigmatic giants' tombs, or Tombe dei Giganti, dating to the Pre-Nuragic phase. These monumental burial sites, hewn from stone and earth, hint at a remarkable understanding of geometry, proportion, and spatial order long before written records or formal architectural treatises emerged. From a distance, the giants' tombs appear as elongated mounds, often flanked by upright stones that rise like sentinels against the horizon. Each tomb is oriented along a consistent axis, typically east-west, with a massive central stele marking the entrance. These entrances lead to galleries or chambers, sometimes carved directly into bedrock, sometimes constructed with megalithic slabs placed with astonishing precision. The scale is impressive. Some tombs reach lengths of 30 meters or more, yet despite their size, the layout demonstrates careful proportionality. Every stone, every alignment suggests deliberate design rather than ad hoc assembly. Archaeological evidence situates the Pre-Nuragic phase roughly between 3,400 and 2,400 BC, a time when Sardinia was inhabited by communities transitioning from scattered settlements to increasingly complex social structures. The giants' tombs are communal, designed to house multiple interments over generations. Unlike later Nuragic structures, which often emphasize fortification or ceremonial towers, these tombs focus on funerary architecture, yet they display an unmistakable geometric awareness. Length, width, and orientation appear standardized across multiple sites, hinting at a shared understanding of proportion and alignment among dispersed communities. The tombs are remarkable not only for scale but for internal arrangement. Long galleries are divided by upright slabs into chambers or niches, often forming sequences of interments that maintain consistent spacing. In some cases, side walls curve gently inward, creating a trapezoidal plan that balances aesthetic proportion with structural stability. The central stele, sometimes adorned with carvings, dominates the facade, providing a focal point and reinforcing symmetry. The repetition of certain dimensions, the width of galleries, the height of stones, the spacing of niche dividers, suggests rules of measurement, even in the absence of written documentation. Orientation is one of the most compelling aspects. Many tombs are aligned along solar axes, with entrances facing the rising sun during solstices or equinoxes. Could these alignments encode calendrical knowledge or cosmological observation? Were they symbolic, representing rebirth and the passage from life to death, or practical, maximizing light and airflow within the burial galleries? The precise reasoning remains uncertain, but the recurrence of these patterns across sites implies intentionality rather than coincidence. Construction techniques further emphasize sophistication. Large megaliths, some weighing several tons, were moved and set with remarkable accuracy. Walls rise in straight lines. Chambers maintain level floors despite uneven terrain. In some tombs, corbelling or interlocking stones demonstrate an understanding of load distribution, ensuring stability for centuries. Even minor variations, introduced to accommodate irregular bedrock or local material constraints, respect overall proportion, demonstrating adaptability within a structured system. Artifacts recovered from the tombs, ceramics, beads, stone tools, offer insight into cultural practices, yet the architectural design itself speaks volumes about intellectual achievement. The layout suggests not only an understanding of measurement and proportion, but a conceptualization of space as an ordered relational system. Galleries, stelae, and niche alignments create a rhythm that guides perception and movement, evoking deliberate harmony rather than random placement. Anomalies add to the intrigue. Some tombs deviate from standard orientation or feature irregular chamber sizes and atypical stone arrangements. Were these variations functional, accommodating terrain, family lineage, or ritual preference? Or could they reflect evolving mathematical knowledge, experimental planning, or symbolic encoding yet to be fully understood? Unlike purely decorative deviations, these anomalies often integrate seamlessly with overall proportion, hinting at intentional complexity rather than error. Comparisons with other mathematical and architectural sites explored in this series illuminate a recurring principle. Geometry and spatial intelligence appear across cultures, continents, and eras. From Dra Abu el-Naga's hidden shafts to Kalasha burial anomalies, Chachapoya cliffside mausoleums, and Harappa cemeteries, human societies consistently embedded proportionality, alignment, and measurement into functional, ritual, and symbolic spaces. In Sardinia, The giants' tombs exemplify this principle in megalithic form, where the scale may be monumental, but the mathematics is embedded in layout, proportion, and orientation. Standing before a giant's tomb today, one senses the intentionality behind every stone and axis. The entrance stele dominates the view, guiding the eye along the gallery's length. Upright slabs, niches, and side walls establish rhythm and proportion, conveying both structural logic and aesthetic balance. Even the massive scale does not overwhelm. Rather, it communicates a disciplined understanding of space and measurement, crafted by a culture capable of applying mathematics to stone, earth, and human need. Yet mysteries endure. How were measurements standardized without written notation? How were stones moved, aligned, and proportioned across uneven terrain? What symbolic or cosmological rules dictated deviations from the norm? And perhaps most compelling, how much knowledge of spatial order, geometry, and applied mathematics has been lost to time, leaving only the silent majesty of stone to hint at past sophistication? The Sardinian giants' tombs remind us that mathematical intelligence need not be abstract or visible in urban grids, temples, or monumental towers. It can reside in the elongation of a tomb, the spacing of niches, the orientation of a stele, or the rhythm of a gallery. Proportion, alignment, and deliberate spatial design are as much a part of prehistoric genius as any monumental construction. And so, as one walks along the mound, tracing the carefully measured galleries and monumental stones, the giants' tombs speak across millennia. They challenge us to recognize intelligence embedded in landscape and construction, to perceive mathematics applied without inscription, and to wonder what other principles of geometry, measurement, and proportionality remain hidden in the megalithic landscapes of Sardinia, waiting to reveal the ingenuity of pre-Nuragic civilizations long past. As the winds of Sardinia whisper over the monumental giants' tombs, where massive stones align with precise proportion and pre-Nuragic intelligence still echoes across millennia, our journey now carries us westward across oceans and time to the mesas and canyons of the American Southwest. Here, on the high plateaus of what is now Colorado, lie the early pre-cliff phase structures of Mesa Verde, a region that would later become famous for its cliff dwellings, but whose initial settlements reveal a surprising sophistication in planning, spatial order, and construction long before humans carved their homes into vertical cliffs. From above, the Mesa Verde landscape presents a vast tapestry of flat-topped mesas, deep canyons, and rocky outcrops bathed in sunlight. Amid this rugged terrain, early Puebloan communities constructed multi-room dwellings, kivas, and storage spaces arranged across mesa tops. Unlike the later cliff dwellings that cling dramatically to overhanging ledges, these pre-cliff phase structures occupy open terrain, yet they display a remarkable understanding of proportion, alignment, and spatial organization. Long rows of rooms, circular ceremonial spaces, and communal plazas form clusters that suggest deliberate planning rather than mere settlement sprawl. Archaeological evidence places the pre-cliff phase roughly between 600 and 1100 AD, preceding the iconic cliff constructions of the late Puebloan period. These early settlements, often called mesa-top villages, demonstrate the Puebloans' capacity to organize domestic, ceremonial, and storage spaces into cohesive layouts. Walls were constructed from sandstone blocks and mud mortar, and rooms were proportioned to accommodate family units, social interaction, and communal activities. The arrangement of these structures reflects careful measurement. Doorways, walls, and interior spaces repeat dimensions, and clusters of rooms appear to follow consistent spatial intervals across multiple villages. The circular kivas, ceremonial subterranean chambers partially built into the earth, are particularly striking. While smaller than their later cliff counterparts, they display careful attention to geometry. Diameter, depth, and internal features like fire pits and benches follow repeated ratios, creating harmony within the space. Were these proportions purely functional, facilitating ritual and acoustics? Or did they also encode symbolic or cosmological significance, linking human activity to patterns observed in the sun, moon, or stars? The consistency across sites suggests intentionality, a careful integration of human needs, ritual, and measurement. Orientation further deepens the intrigue. Many structures align with cardinal points or key topographical features, ridgelines, water sources, and overlooks. Some villages appear designed to maximize sunlight, wind flow, or visibility across the mesa, while others maintain relationships with distant features, hinting at a spatial awareness that extends beyond the immediate settlement. Could these alignments encode knowledge of landscape, seasonal cycles, or social hierarchy? The evidence suggests that pre-cliff phase Puebloans were conscious planners, applying geometry and spatial intelligence to organize life, ritual, and observation across the mesas. Construction techniques reinforce this impression. Walls are level, corners squared, and stones fitted carefully to maintain stability and proportion. Internal partitions within dwellings create consistent room sizes, facilitating both domestic function and communal harmony. Courtyards and plazas are positioned to maintain open sightlines, while storage pits and ancillary spaces reflect modular planning. Even subtle variations, adapted to topography or available materials, maintain overall proportionality, suggesting a flexible but disciplined understanding of spatial rules. Some anomalies in these early structures are particularly intriguing. Certain clusters deviate from the standard room alignment, or incorporate unusually shaped rooms or larger ceremonial spaces. Were these deviations functional, reflecting adaptation to irregular terrain, or social, distinguishing elite or ritual areas? Might they also indicate experimentation with proportional rules or early mathematical knowledge embedded in construction practice? While definitive answers remain elusive, the anomalies invite reflection on the ways early architects balanced consistency with innovation. Comparisons with other sites in this series reveal a striking global pattern. Human societies repeatedly integrate measurement, geometry, and proportionality into both daily and sacred spaces. From Sardinia's giants' tombs to Dra Abu el-Naga's hidden shafts, from Kalasha burial anomalies to Chachapoya cliffside mausoleums, we observe that mathematical intelligence manifests across cultures and continents, often in subtle yet deliberate ways. Mesa Verde's pre-cliff phase structures exemplify this principle. Geometry is embedded not in monumental stone alone, but in settlement layout, room proportion, and spatial relationships across the landscape. Walking among these early mesa-top dwellings today, one senses the intelligence woven into the fabric of the landscape. Walls and courtyards, kivas and plazas, all communicate an understanding of proportion, alignment, and relational space. Even eroded stones and collapsed walls convey a rhythm of measurement and spatial order, a logic that guided not only construction but social and ceremonial life. These structures were not arbitrary. They were calculated, observed, and maintained over generations, reflecting a culture attuned to both human and environmental needs. Yet much remains unresolved. How were these proportional rules determined and transmitted in the absence of written notation? To what extent did astronomical, seasonal, or cosmological observation influence village layout? And how did the pre-cliff phase settlements inform the later, more famous cliff dwellings that seemed to defy gravity while maintaining similar principles of alignment, proportion, and modularity? The questions underscore a pattern seen in this series. Intelligence, mathematics, and observation often leave tangible traces, yet their full reasoning remains tantalizingly out of reach. The pre-cliff phase structures of Mesa Verde remind us that mathematics can be both practical and subtle. Proportions govern domestic space, alignment guides communal interaction, and geometry informs ritual architecture. This intelligence does not require written language. It is encoded in stone, earth, and spatial relationships, transmitted through observation, apprenticeship, and cultural practice. Here, on the high mesas of Colorado, mathematics, environment, and social organization converge in a form both functional and harmonious. And so, as one walks among the terraces, room clusters, and circular kivas of these early settlements, the pre-cliff phase structures whisper across the centuries. They invite us to consider the subtle application of geometry, the deliberate measurement of space, and the relational intelligence that guided human habitation long before written records. In the mesas and canyons of the Southwest, as across Sardinia, Egypt, and beyond, mathematics reveals itself not as abstract theory, but as lived, measured, and enduring human ingenuity awaiting patient observation to uncover its full depth.